There was a time when being human did not mean being Homo sapiens. 50,000 years ago, if you could have crossed the earth from west to east, moving slowly beneath the enormous night sky, you might have encountered several very different kinds of human beings. In the cold valleys of Europe, Neanderthals gathered around fires they had learned to control countless generations before. They shaped stone, hunted enormous animals, cared for injured companions, and carried children through landscapes of snow and grass. Farther east, somewhere across the immense spaces of Asia, people related to the Denisovans lived in environments ranging from the mountains of Siberia to the thin air of the Tibetan Plateau. On distant islands in Southeast Asia, small-bodied humans survived in worlds cut off by sea. And somewhere among all of them were our own ancestors, Homo sapiens. They did not know that they were destined to inherit the planet. They did not know that one day their descendants would build cities large enough to glow from space, cross oceans in hours, reconstruct extinct genomes, and look backward through tens of thousands of years in an attempt to understand what happened. At the time, Homo sapiens was simply one human lineage among several, and there was no obvious reason why ours had to be the last. Neanderthals had survived brutal climatic changes for hundreds of thousands of years. Denisovan-related populations occupied environments that challenged the limits of human endurance. Other human groups had adapted to islands, forests, mountains, and unfamiliar ecosystems in ways we are only beginning to understand. Yet, one by one, the separate human lineages disappear from the archaeological record. By the end of the Pleistocene, the human family tree had been dramatically reduced. Only one surviving human species remained: us. Why? Perhaps Homo sapiens possessed better weapons. Perhaps our ancestors communicated more effectively. Perhaps larger social networks allowed knowledge, food, materials, and partners to move between distant communities. Perhaps our ability to survive on many different kinds of food protected us when climates changed and familiar animals disappeared. Perhaps population size mattered more than intelligence. Perhaps disease played a role. Perhaps chance played a greater role than we would like to admit. And perhaps the deepest mistake is hidden inside the question itself. Because the other humans did not entirely disappear. When ancient genetic material was finally recovered from their bones, scientists discovered something remarkable. Our ancestors had met them, and sometimes they had children together. Parts of those ancient populations still travel through the human story, carried quietly inside the genomes of people alive today. So this is not simply the story of how Homo sapiens defeated every rival. It is the story of changing climates, fragile populations, unexpected meetings, distant migrations, shared knowledge, inherited genes, and thousands of small events whose consequences accumulated across generations. Tonight, we will return to that vanished world, a world in which humanity had many faces, and we will begin on a cold night, roughly 50,000 years ago, when no one yet knew which branch of the human family tree would survive. Imagine that the year is approximately 50,000 years before the present. There are no maps. There are no written borders. There are no nations, no roads, no permanent lights shining across the continents. The darkness at night is almost complete. Above the landscape, the Milky Way stretches from horizon to horizon with a clarity that few modern people will ever see. In what will one day be called Europe, winter has settled over a wide valley. The air smells of cold stone, smoke, animal hide, and damp earth. A small fire burns beneath a rocky shelter. Around it sit several people. One of them holds a stone tool in his hand. Its cutting edge has become dull after repeated use. He strikes it carefully with another stone. A thin flake breaks away. He turns the tool slightly. Another strike. Another flake. The edge grows sharp again. Nearby, someone pulls apart pieces of meat from an animal killed earlier in the day. A child watches the adults. An older individual sits close to the fire. Perhaps this person carries an injury that healed years before. Perhaps someone helped this person survive when survival alone would have been difficult. These people are Neanderthals. They are not monsters. They are not unfinished versions of us. They are not stupid creatures waiting for a more advanced species to arrive. They are human beings from another branch of the human family. And on this particular night, they have no reason to imagine that their lineage will one day vanish. They have already survived for an extraordinary length of time. Their ancestors lived through repeated glacial cycles, changes in vegetation, shifting animal populations, bitter winters, warmer intervals, droughts, and migrations. Generation after generation, Neanderthals learned the geography of their world. They knew where animals moved. They knew where certain kinds of stone could be found. They knew how to make fire useful. They knew how to transform the body of an animal into food, hide, sinew, bone, and tools. They knew how to remain alive in places where an unprepared modern person could die within days. They belonged there. And yet they were not alone. Far beyond this valley, other kinds of humans were alive. To the east, across landscapes that would later become parts of Russia, Mongolia, China, and Central Asia, lived populations whose full story remains frustratingly incomplete. One of these populations is known today through an almost impossibly small collection of physical remains. A finger bone, several teeth, fragments of bone, and genetic material preserved for tens of thousands of years in the cold darkness of a cave. We call them Denisovans. The name does not come from anything they called themselves. We do not know what they called themselves. We do not know what languages they spoke. We do not know the stories they told their children. We do not know what they thought when they looked at mountains, storms, animals, fire, birth, or death. Their modern name comes from Denisova Cave in the Altai Mountains of Siberia, where evidence of their existence was identified. And even that evidence has created more questions than answers. The Denisovans appear to have been part of a human population, or perhaps several related populations, spread across enormous portions of Asia. Genetic traces linked to them survive today in populations far from Siberia, especially among some peoples of Oceania and parts of Southeast Asia. Other Denisovan-related genetic contributions are found among populations in Asia. This tells us something remarkable. The Denisovan world was probably much larger and more complicated than the handful of bones currently known to science. Some Denisovan-related people also contributed genetic variants associated with survival at high altitude. Among Tibetan populations, one important variant affecting the body response to low oxygen appears to have entered Homo sapiens through ancient interbreeding with a Denisovan-related population. Long before modern evolutionary biology existed, two human lineages met. They had children. And tens of thousands of years later, descendants of those encounters carried inherited adaptations into one of the harshest environments inhabited by humans. But even Denisovans and Neanderthals do not complete the picture. Travel farther south. Cross coastlines very different from those of the modern world. Sea levels during glacial periods were lower because enormous quantities of water were locked inside ice sheets. Land extended into areas that are now beneath the ocean. Some islands were larger. Some coastlines were farther away. But deep channels of water still separated certain places. On the Indonesian island of Flores lived another kind of human, Homo floresiensis. They were small. Their bodies stood only a little more than 1 meter tall. Their brains were much smaller than those of modern humans, and yet they were part of a human lineage that survived on Flores for a very long time. The story of Homo floresiensis is one of the strangest chapters in human evolution. Their remains were discovered in Liang Bua Cave. At first, their unusual anatomy produced intense debate. How could such a small-bodied, small-brained human exist so recently? Were they members of Homo sapiens affected by disease? Or did they represent a separate branch of the human family? Over time, evidence increasingly supported the second explanation. They appear to represent a distinct human lineage with deep evolutionary roots. Flores was already an unusual place. Island ecosystems often create evolutionary experiments that would be unlikely on large continents. Large animals may become smaller. Small animals may become larger. Species can follow isolated evolutionary paths for hundreds of thousands of years. On Flores, dwarf elephants known as stegodonts once lived alongside giant rats, enormous birds, reptiles, and small humans. Try to imagine that landscape before sleeping tonight. Tropical vegetation, volcanic hills, the sound of insects after sunset, a fire glowing near the mouth of a cave, a human silhouette barely more than 1 meter tall moving through the darkness. The people of Flores were not characters in mythology. They were real. And for at least part of their history, somewhere beyond the sea, other human lineages were also living. Farther north, in the Philippines, another surprise waited inside Calao Cave on the island of Luzon. Teeth and bones discovered there were eventually assigned to another named human species, Homo luzonensis. Once again, the evidence was fragmentary. Once again, the discovery reminded scientists how incomplete the human family album remains. The fossils showed a curious combination of characteristics. Some appeared relatively recent. Others seemed more ancient. It was as though evolution had preserved different features in combinations no one had expected. And Homo luzonensis may not be the final surprise. Genetic studies of living humans suggest that ancient Homo sapiens populations probably encountered human groups whose fossils have not yet been securely identified. Researchers sometimes refer cautiously to such populations as ghost populations. The phrase sounds mysterious, but its meaning is simple. Sometimes genetic patterns reveal that interbreeding occurred with an ancient population, even when archaeology has not yet provided enough bones to tell us exactly who that population was. Their bodies may still lie undiscovered. Their fossils may have vanished. They may already sit unnoticed in a museum drawer. Or perhaps tropical heat and acidic soil destroyed much of the genetic material and bone that could have preserved their story. The past is not a complete library. It is more like a library after a fire. A few shelves remain. A few pages survive. Sometimes we have only a sentence. Sometimes only a word. And from those fragments, researchers attempt to reconstruct an entire world. This makes one of our most familiar ideas about humanity surprisingly recent. Today, every person you will ever meet belongs to the same surviving human species. People differ in appearance, language, ancestry, culture, religion, diet, traditions, and countless other features. But biologically, every living person is Homo sapiens. That feels normal because it is the only condition we have ever known. For much of human prehistory, however, it was not normal at all. The human family tree once had multiple living branches. Our ancestors may have walked through landscapes knowing that somewhere beyond the next mountain, another kind of human lived. Perhaps they recognized the difference immediately. Perhaps it was subtler than we imagine. A face slightly different. A body built differently. A different style of clothing. A different tool. A different language. A different way of organizing a camp. What happened when such groups met? For many years, popular imagination preferred a simple answer. Conflict. One group encounters another. The stronger group wins. The weaker group disappears. It is an easy story to understand. It is also almost certainly incomplete. Ancient human populations did compete. Two groups living in the same landscape could seek the same water, the same stone, the same shelter, the same animals, and the same edible plants. Competition must have occurred. Violence also existed among prehistoric humans. There is no reason to imagine a peaceful ancient world untouched by fear, territoriality, revenge, or conflict. But violence is only one possible relationship between human groups. People can also avoid one another. They can exchange objects. They can observe techniques from a distance. They can move into abandoned territory. They can communicate. They can form alliances. And they can reproduce together. This last possibility completely transformed our understanding of human evolution. For a long time, Neanderthals were often imagined as an evolutionary dead end, separated clearly from modern humans. Then ancient genetic research changed the picture. Scientists recovered Neanderthal genetic material and compared it with the genomes of living people. The results showed that ancestors of many modern humans had interbred with Neanderthals. Today, most people with substantial ancestry outside sub-Saharan Africa carry a small percentage of Neanderthal-derived genetic material, although the precise amount and distribution vary among individuals and populations. This means the meeting between Homo sapiens and Neanderthals was not merely a confrontation between strangers. Sometimes it became something far more intimate. Somewhere tens of thousands of years ago, a Neanderthal and a Homo sapiens had a child. That child survived long enough for descendants to continue. Then their descendants had descendants. The genetic inheritance traveled onward through countless births. Kingdoms rose and disappeared. Languages formed and vanished. Ice sheets retreated. Coastlines moved. Agriculture appeared. Cities emerged. And still, fragments of that ancient encounter remained. The same was true with Denisovan-related populations. Homo sapiens did not simply enter Eurasia and erase every human already there. The reality was more tangled. Migration, competition, replacement, absorption, interbreeding, isolation, population decline. All of these processes could occur in different places and at different times. Even the word species becomes slightly uncomfortable when discussing these ancient humans. In school, species are often presented as neatly separated biological boxes. One species belongs here. Another belongs there. But evolution does not always respect the categories humans later invent. Closely related populations can diverge gradually. They can remain separate for long periods. They can meet again. They can exchange genes. Then they can separate once more. Neanderthals, Denisovans, Homo Sapiens, and perhaps other ancient populations formed a complicated network of relationships over hundreds of thousands of years. A branching tree is useful, but sometimes a braided river is a better image. Channels divide, flow separately, reconnect, divide again, and eventually some channels disappear while their water continues downstream in another course. That is important because the central mystery of our story is often phrased too simply. Why did Homo sapiens survive while every other human species became extinct? The question suggests that every lineage faced a final competition and that one winner remained. But the true history may have looked very different. Some populations certainly died out. Some became so small that chance alone may have pushed them beyond recovery. Some could have been affected by climatic instability. Some may have suffered when prey animals moved or vanished. Some may have faced competition from expanding Homo sapiens populations. Some may have been exposed to unfamiliar diseases. And some may have been gradually absorbed into larger populations until they no longer existed as separate communities. Imagine a very small human population. Perhaps there are only a few thousand individuals scattered across an enormous territory. They do not live together. They exist in bands separated by valleys, mountains, rivers, and days of travel. Now imagine that births decline slightly. A few infants do not survive. A hunting accident kills 2 experienced adults. Another group loses several people during a severe winter. A distant community becomes isolated. Young adults have difficulty finding partners outside their immediate relatives. Nothing spectacular has happened. There is no final battle. There is no moment that deserves to be called extinction. There is only a slow narrowing of possibilities. One camp is abandoned, then another. A route between communities is no longer traveled. Knowledge once shared between groups becomes trapped within a single small population. And when the last members of one regional community disappear, no one outside that landscape records the event. There is no historian, no monument, no date, no final sentence, only silence. This is one reason prehistoric extinction is so difficult to explain. Archaeology rarely gives us a continuous film. Instead, it gives us fragments. A hearth, a tooth, a stone point, a butchered animal bone, a layer of charcoal, a trace of pigment, a footprint hardened in sediment. Sometimes tens of thousands of years separate one discovery from the next. From these fragments, researchers estimate when populations appeared, where they moved, what they ate, what technologies they used, and when their distinctive archaeological traces ceased. But disappearance from the archaeological record does not always mean immediate biological extinction. A population may move. Its archaeological traditions may change. Its members may interbreed with newcomers. Its numbers may become too small to leave obvious traces. This is why the final centuries of a human lineage cannot usually be described like the fall of a city. There may never have been a final Neanderthal camp where the last members understood that everyone like them was gone. Instead, the ending may have unfolded unevenly across continents. Some Neanderthal communities disappeared earlier. Others persisted longer. Some probably met Homo sapiens repeatedly. Some may have lived for generations without encountering them at all. The same caution applies to the other human populations. Homo floresiensis lived in an island environment unlike Neanderthal Europe. Homo luzonensis occupied another island setting. Denisovan-related populations seem to have been distributed across diverse parts of Asia. There is no reason to expect one universal explanation for every disappearance. That brings us to the most important idea of this entire story. Homo sapiens' survival was probably not caused by a single superior trait. There was no one magical invention, no single mutation, no single battle, no single moment when evolution declared a winner. Instead, our survival appears to have emerged from interactions among many advantages and many accidents. Population size, mobility, social relationships, technology, ecological flexibility, communication, diet, climate, interbreeding, geography, and chance. Some of these factors may have mattered enormously in one region and much less in another. A larger network might save a population during famine. A better projectile could reduce the danger of hunting. A wider diet could become critical when large animals became scarce. A marriage between people from distant groups could strengthen social ties and maintain genetic diversity. A warmer century could open a migration route. A colder century could close it. History is often changed not by one great cause, but by many small pressures acting together. And 50,000 years ago, none of those pressures had finished their work. Return now to that first Neanderthal camp. The fire has burned lower. The stone tool has been sharpened. The meat has been divided. Perhaps the child who watched the adults earlier has fallen asleep beneath animal hides. Beyond the shelter, the valley is dark. The people around the fire know this landscape intimately. Their ancestors have lived across Europe and Western Asia for longer than Homo sapiens has been present there. They are physically powerful. They are knowledgeable. They are adaptable. They are experienced survivors. If you stood beside their fire and somehow knew the future, the mystery would feel even greater. Because nothing about them looks like a people destined to disappear. And nothing about the scattered Homo sapiens populations moving through distant valleys makes our eventual dominance appear inevitable. Yet within several thousand years, the balance will change. Neanderthal populations will become smaller and rarer. Their distinctive presence will fade from the archaeological record. Homo sapiens populations will continue expanding. And eventually, one branch of humanity will remain as an independent surviving species. To understand how this could happen, we must resist the old caricature of the Neanderthal as a brutish creature defeated by a cleverer human. We must enter their world on its own terms. We must understand the bodies that carried them through glacial winters, the tools they made, the animals they hunted, the injuries they survived, the communities they depended upon, and the quiet demographic weakness that may have existed beneath their extraordinary ability to endure. Because the strongest rival Homo sapiens encountered was not weak. Neanderthals had already survived worlds that would have killed most of us. And that makes their disappearance far more mysterious. In the next chapter, we will travel deeper into Ice Age Europe, following the Neanderthals through frozen grasslands, forests, caves, hunting grounds, and generations of climatic change. There we will discover a people far more capable than the old stereotypes suggested. And we will begin to see why physical strength alone was never enough to guarantee survival. Long before Homo sapiens became common in Europe, another kind of human already knew its winters. They knew the valleys where herds passed in autumn. They knew which cliffs offered shelter from the wind. They knew where flint could be collected from exposed stone, where water remained accessible during cold months, and where animals might gather when snow covered the higher ground. To understand what happened to the Neanderthals, we have to begin with this simple fact. They were not newcomers to the Ice Age world. They were its veterans. For hundreds of thousands of years, Neanderthal populations and their ancestors lived across large parts of Europe and Western Asia. Their world repeatedly shifted between colder and warmer phases. Forests expanded, then retreated. Grasslands opened. Ice sheets advanced. Rivers changed course. Animals moved north and south as climates transformed the land around them. Through all of this, Neanderthals survived. So imagine Europe during one of the colder periods of the late Pleistocene. The landscape is not necessarily buried beneath endless snow. That familiar image can be misleading. Much of Ice Age Europe contains open steppe, patches of woodland, rocky valleys, river corridors, and wide grasslands exposed to strong winds. On these plains move animals that would seem almost mythical today. Woolly mammoths, woolly rhinoceroses, reindeer, wild horses, bison, large deer, ibex in mountainous regions. Predators also share this world. Cave lions, wolves, hyenas, bears. For a human being moving through such a landscape, survival demands an extraordinary amount of practical knowledge. A modern visitor might see an empty plain. A Neanderthal hunter might see tracks, wind direction, fresh dung, broken vegetation, a route toward water, the likely position of a herd, the location of shelter if weather suddenly changes, and perhaps the signs of another group of humans who passed through several days before. Knowledge like this does not fossilize. We cannot excavate a memory. We cannot recover a conversation from 50,000 years ago. But the archaeological record allows us to glimpse the consequences of knowledge. Stone tools appear at places where animals were butchered. Bones show cut marks. Hearths preserve charcoal. Caves preserve layers of repeated occupation. Injuries healed during life reveal that individuals survived wounds that might have been difficult to endure alone. Taken together, these traces describe people who were deeply adapted to their environment, and their bodies reflected that adaptation. The typical Neanderthal body was powerful. Compared with many modern humans, Neanderthals tended to have shorter limbs, broad trunks, robust bones, and heavily muscled frames. Their faces were distinctive. They had large noses, prominent brow ridges, and skulls shaped differently from ours. Their brains were large, often comparable in volume to or larger than those of modern Homo sapiens, although brain size alone tells us very little about intelligence. What matters is that their anatomy was not primitive in the sense of being unfinished. It was specialized. A compact body loses heat more slowly than a long, narrow one. Shorter lower limbs reduce surface area. A wide torso may help conserve warmth. These are useful characteristics in cold environments. The Neanderthal body was not a failed attempt at becoming modern. It was the result of generations surviving conditions that rewarded a particular kind of human form. But maintaining such a body was expensive. Muscle requires energy. A large body requires calories. Living in cold climates increases energetic demands further. Neanderthals probably needed substantial food, especially during difficult seasons. Much of that food came from animals. Evidence from many sites suggests that Neanderthals were highly capable hunters of large mammals. This is another place where an old stereotype begins to disappear. Earlier popular images sometimes showed Neanderthals scavenging whatever stronger predators left behind. We now know that they frequently hunted, and they sometimes hunted dangerously large prey. Consider what this means. A horse is powerful. A bison is enormous. A wild bovine can kill a person with a single charge. A rhinoceros is not something an unarmed primate should approach at all. Yet Neanderthals repeatedly acquired meat from large animals. The details varied by region, period, prey, and hunting strategy, but close-range hunting appears to have been important. Wooden spears existed in the Pleistocene long before the final Neanderthals, and Neanderthals used stone-tipped hunting weapons as well. Some weapons may have been thrust or thrown at relatively short distances. This could place hunters dangerously close to their prey, and Neanderthal skeletons sometimes show serious injuries, broken bones, damage to limbs, trauma that healed. It is tempting to imagine an individual struck by an animal, surviving the initial injury, and then depending on companions while recovery took place. We cannot know the story behind every healed bone. But some Neanderthals clearly survived long after injuries that would have made independent survival difficult. This matters because it tells us something about their social world. A severely injured person consumes food. A person unable to hunt may need help moving. Someone with impaired mobility may require protection. If that individual survives for months or years, then other people are probably involved. Care is not unique to Homo sapiens. Neanderthals appear to have cared for members of their communities. There are individuals who lived with serious physical problems well into adulthood. There are elderly Neanderthals who survived extensive tooth loss. There are skeletons with injuries that healed. We should be cautious about projecting modern emotions directly onto the past. But survival under those circumstances suggests social bonds. The Neanderthal campfire was not simply a temporary gathering of strong hunters. It was a community. There were children, parents, older people, injured individuals, experienced toolmakers, people who knew landscapes and seasons, people who depended on one another. Around that fire, knowledge was transferred. A child could watch how stone was struck, where to hold the core, at what angle to strike, how hard, which fracture was useful, which piece should be discarded. Stone tool manufacture can appear simple when we see the finished object behind museum glass, but shaping stone deliberately requires skill. Hit the wrong place and the stone breaks uselessly. Strike at the wrong angle and the desired flake does not detach. Choose poor material and the edge fails. Neanderthals used sophisticated methods of preparing stone cores so that flakes of predictable shapes could be removed. One famous approach is known as the Levallois technique. It involves planning. The toolmaker prepares the surface of a stone core in advance, shaping its geometry so that a later blow removes a useful flake. The final strike may take only a moment, but the form of that flake has been prepared through a sequence of earlier decisions. In that sense, the object begins to exist in the mind before it exists in the hand. Neanderthals also produced different kinds of scrapers, points, and cutting tools. Some stone points were probably attached to wooden shafts. That requires more than stoneworking. It requires combining materials: wood, stone, perhaps sinew or plant fiber, natural adhesives in some contexts. A tool assembled from several materials is a small technological system, and systems require planning. Fire added another layer of control. Around a fire, meat could be cooked. Wood could be hardened or worked. Light extended activity after sunset. Heat made cold shelters more tolerable. Smoke may have helped with insects or other practical tasks. Fire transformed space. Beyond the light was darkness. Inside it was a human environment, a place where food could be shared, tools repaired, children watched, stories perhaps told. We do not know what language Neanderthals possessed. This question has inspired arguments for decades. Older theories sometimes imagine them as nearly speechless. That view has become increasingly difficult to defend. Their anatomy, genetic evidence, hearing capacities, and complex behavior all suggest that Neanderthals were capable of sophisticated vocal communication. But exactly what their language was like cannot be recovered. We do not know whether their speech contained grammar comparable to ours. We do not know the size of their vocabularies. We do not know whether they told elaborate narratives. We do not know whether they named generations of ancestors or described events decades in the past. The safest conclusion is not that Neanderthals lacked language. It is that the nature of their communication remains uncertain. And uncertainty is important in this story, because whenever we ask why Homo sapiens survived, there is a temptation to invent a simple, missing ability in everyone else. Perhaps they could not speak. Perhaps they could not imagine. Perhaps they could not plan. Perhaps they could not cooperate. Each explanation makes our success feel inevitable. But archaeological discoveries repeatedly complicate those claims. Neanderthals used pigments. They collected unusual objects. At some sites, researchers have identified modified eagle claws that may have been used ornamentally. There is evidence suggesting that feathers or other bird parts may sometimes have been deliberately collected. There are controversial examples of markings and cave features that could have symbolic significance. The details remain debated. But the broader picture is increasingly difficult to reconcile with the idea of a mentally simple population. Neanderthals were capable. And that makes the real differences between them and Homo sapiens harder to identify. Perhaps the crucial difference was not what a single Neanderthal could do. Perhaps it was what happened when many individuals were connected across space. To see why, imagine two communities. The first consists of 25 people. They know one another closely. Their territory is familiar. They have a good hunting strategy. Several adults are skilled tool makers. An older member remembers where animals gathered during a severe winter many years earlier. For decades, the group survives successfully. But its social world is small. Another community lives several days away. Contact is rare. Another lies beyond the mountains and may never be visited. Now imagine a difficult year. Animals shift their migration route. One experienced hunter dies. A child becomes ill. Two young adults leave. A source of stone becomes inaccessible. The group still has intelligence. It still has knowledge, but it has lost redundancy. If only one person knows a particular skill and that person dies, the skill may disappear. If only a few potential partners are available, reproduction becomes more difficult. If neighboring groups are distant or declining, help cannot easily arrive. Population size changes the meaning of misfortune. The same accident that barely affects a population of several thousand can devastate a community of 20. This may have been one of the great vulnerabilities of Neanderthal life. Genetic evidence suggests that Neanderthal populations were often small. They may have existed at relatively low population densities across enormous territories. Some groups were isolated for long periods. Levels of genetic diversity were lower than in many Homo sapiens populations. There is evidence of close relatedness within certain local groups. This does not mean every Neanderthal lived in a tiny, isolated band without wider contacts. The archaeological record shows movement of materials and repeated occupation across landscapes. But overall, their demographic world appears to have been thinly populated. And in evolution, numbers matter. A small population can be perfectly adapted and still be fragile. Suppose 10 groups occupy a region. If 2 disappear after a severe climatic event, neighboring groups may eventually repopulate the empty territory. But suppose only 3 groups remain. One fails to reproduce successfully. One becomes isolated. The third suffers several accidental deaths. Soon, an entire region can become empty. No superior enemy is required. No great catastrophe is required. Extinction can begin quietly. Demographers sometimes describe these processes using probabilities. But imagine them instead as fires at night. Each camp is a small light in a vast landscape. As long as enough lights remain within reach of one another, people can move between them. Partners can be found. Knowledge can travel. A group that loses members may recover. Now imagine those lights growing farther apart. One goes dark, then another. The journey between surviving camps becomes longer. A family that once visited neighbors every season now sees them every few years. Eventually, one camp remains where 5 once burned. That final group may still be strong. Its hunters may still be excellent. Its tools may still be sharp. But its future has become uncertain. This is the difference between individual survival and population survival. Evolution does not ask whether one person is powerful. It asks whether enough descendants continue. Neanderthals had survived repeated environmental changes before Homo sapiens became widespread in Europe. So climate alone cannot provide a simple answer. They had endured cold periods. They had endured warmer periods. They had changed their territories. They had adapted their behavior. Yet the late Pleistocene presented a particularly complex combination of pressures. Climate could fluctuate rapidly. Habitats shifted. Animal populations moved. And at the same time, another human population was entering or expanding into many of the same regions. Homo sapiens. The earliest movements of Homo sapiens beyond Africa were not a single march. There were likely multiple dispersals over long periods. Some populations reached the Levant far earlier than the major later expansion across Eurasia. Some movements may have failed or left little genetic legacy. Others eventually produced populations that expanded widely. By around 45,000 years ago, Homo sapiens was established across substantial parts of Europe. In many places, Neanderthals were still present. Now imagine the first encounter. It may not have happened suddenly. Perhaps signs came first. A stone tool made in an unfamiliar way. Tracks near a water source. A hearth still warm but abandoned. Animal bones cut differently. A distant column of smoke. Then, one day, people. Humans. But not exactly familiar humans. What did they think of one another? We cannot know. Perhaps fear, perhaps fascination, perhaps immediate hostility, perhaps cautious observation, perhaps nothing more dramatic than recognition that another group had entered the same landscape. For a Neanderthal community, Homo sapiens would not necessarily appear overwhelming. A small band of newcomers was simply another small band of humans. They could be avoided, driven away, tolerated, perhaps traded with, perhaps joined. The danger, if there was one, may not have been obvious at the scale of a single encounter. The deeper difference may have emerged over generations. If Homo sapiens populations were more numerous, if they maintained wider social connections, if individuals moved more frequently between groups, then sapiens could recover from local failure more effectively. When one camp disappeared, another might replace it. When one source of food declined, information about alternatives might travel through social ties. When particular resources were unavailable locally, materials could arrive from farther away. And when a group needed partners, a wider network could provide them. This is not the dramatic advantage of a new weapon. It is more subtle. But subtle advantages become powerful when repeated thousands of times. Consider two populations sharing a continent for 5,000 years. One has a slightly higher average survival rate. Its communities are slightly larger. Its social networks are slightly broader. Its technology spreads slightly more reliably. Its young adults have slightly more opportunities to move between groups. Its members can exploit slightly more types of food. In any single year, the difference might be invisible. After 200 generations, it could transform a continent. And yet competition is only part of the story. Because genetic evidence tells us that some of those encounters did not end with one group driving the other away. They ended with children. This fact changes the emotional landscape of Neanderthal disappearance. Imagine a small Neanderthal group living near a larger Homo sapiens population. Over generations, individuals move between communities. Perhaps a Neanderthal woman joins a sapiens group. Perhaps a sapiens man becomes part of another community. Children are born with ancestry from both populations. Then those children become parents. If one population is much larger, repeated interbreeding can gradually absorb ancestry from the smaller one. The smaller community may disappear as a distinct population without every member dying. Its lineage continues inside another. This is called assimilation. And it may have contributed to what happened. We should not imagine assimilation as necessarily peaceful. Nor should we assume it happened everywhere. Human relationships can include cooperation and violence at the same time. Different regions may have experienced very different histories, but the genetic evidence ensures that at least some Neanderthals became ancestors of later humans. That means the sentence Neanderthals went extinct is both true and incomplete. As a distinct population, they disappeared. As contributors to the ancestry of living Homo sapiens, they did not vanish entirely. Some of their DNA remains. Fragments of an ancient population carried through bodies that no Neanderthal could ever have imagined. And so, by the time we look at Europe around 40,000 years ago, the picture is not one of a simple battlefield. It is a mosaic. Neanderthal groups living in some regions, Homo sapiens groups appearing in others, cultural traditions changing, populations moving, climate fluctuating, communities encountering one another, occasional interbreeding, local extinctions, local expansions, perhaps periods when territory changed hands without anyone understanding the continental pattern. Eventually, however, the pattern becomes unmistakable to us. Neanderthal traces become rarer, then they cease. The precise timing differs depending on region and on how archaeological layers are dated, but by roughly 40,000 years ago, Neanderthals had disappeared as a distinct population from most of their former range. For a lineage that had survived for hundreds of thousands of years, the final contraction appears relatively rapid. Still, rapid in prehistory can mean thousands of years, generations of human lives, children born, people growing old, hunters learning landscapes, winters passing. No individual would have experienced the entire decline. A person living during the final Neanderthal millennia might have known only one valley. Perhaps neighboring groups had become harder to find. Perhaps unfamiliar people appeared more often. Perhaps animals moved differently than the elders remembered. Perhaps a traditional campsite was abandoned. But no one stood outside history watching the curve fall toward extinction. They simply lived. That is one of the quiet tragedies of deep time. The people inside an ending rarely know they are living through one. Now imagine the last fire in one particular valley, not the last Neanderthal fire on Earth. We could never identify such a moment. Just the last fire in this place. For centuries, perhaps for millennia, Neanderthals have returned here. Children learned to walk here. Tools were made here. Animals were butchered here. Stories, whatever form they took, were told here. One autumn, a group leaves. Perhaps they follow game south. Perhaps they join relatives. Perhaps they move toward a warmer region. Perhaps they never return because there are too few of them. Winter arrives. Snow settles around the shelter. The hearth fills with sediment. Another season passes, then another. Years become centuries. Eventually, another group of humans may enter the valley. Homo Sapiens. They may notice stone flakes from an earlier occupation. They may have no idea who made them. Or perhaps stories about the other people still survive. We will never know. What we do know is that Neanderthals were not defeated because they were incapable of surviving Ice Age Europe. They had already demonstrated the opposite. They were skilled hunters, experienced toolmakers, users of fire, social beings capable of care. Humans adapted to difficult environments. Their vulnerability may have existed at another scale, not inside the individual body, but between bodies, between camps, between generations. In the number of people available to preserve knowledge, find partners, recover from disaster, and reconnect a landscape after local populations disappeared. And this leads us toward one of the most important possibilities in the entire mystery. Perhaps Homo sapiens did not succeed because each sapiens individual possessed a dramatically superior mind. Perhaps our greatest advantage was created when individual minds were linked together, across valleys, across coastlines, across generations, through exchange, through marriage, through symbols, through stories, through the movement of stone, shells, pigments, tools, and information. A single human brain is remarkable, but a network of human brains can remember far more than any individual. It can preserve solutions discovered generations earlier. It can borrow ideas from people never personally met. It can survive the death of experts. It can transform knowledge into something larger than the life of the person who first discovered it. And somewhere in the late Pleistocene, that invisible network may have begun to change the balance between human populations. Not through a single conquest, not through a single invention, but through connection. In the next chapter, We will follow those connections. We will trace objects moving across landscapes, people moving between communities, knowledge traveling farther than any one hunter could walk in a day, and relationships stretching beyond the immediate family. Because perhaps the most powerful survival technology Homo sapiens ever possessed was not made from stone, bone, wood, or fire. Perhaps it was made from other people. There is a kind of technology that leaves almost no trace in the ground. It does not survive as stone. It does not preserve as bone. It cannot be found as a blade, a needle, a hearth, or a spear point. And yet it may have been one of the most important technologies Homo sapiens ever developed. Connection. Imagine two small groups of humans living in neighboring valleys 45,000 years ago. Each group has 30 people. Each group understands its own landscape. Each knows how to make fire, shape stone, butcher animals, recognize edible plants, and survive the changing seasons. At first glance, there may be little difference between them. But now imagine that the first group is almost alone. Its members occasionally encounter another band, but contact is rare. The second group belongs to a wider web. A sister lives 2 days to the west. A brother joined another community near the river. A hunting partner has relatives beyond the mountains. People gather at certain times of year. Stone moves between territories. Shells from distant coastlines appear far inland. Pigments travel. Stories travel. Marriage partners travel. Information travels. The two groups may contain the same number of people, but they do not contain the same amount of available knowledge. And when the world becomes difficult, that difference can matter. Suppose winter arrives early. The animals usually hunted in one valley have moved elsewhere. A local water source freezes. A firewood supply becomes difficult to reach. A small, isolated group has only its own memory to depend upon. If nobody knows where the herds went, the group faces a serious problem. But a connected group may have another option. Someone remembers that relatives living farther south saw large herds crossing a river. Someone else knows a pass through the hills. A visitor from another community explains that animals have gathered near a distant lake. The information may be imperfect. It may arrive slowly. But even partial information can change survival. This is the invisible advantage of a network. A network allows a group to possess knowledge that no single member discovered. It allows people to survive using information gathered far beyond the territory they personally know. And archaeological evidence suggests that some Homo sapiens populations built surprisingly extensive networks. We see traces of this in materials transported over long distances. Stone from one geological source may appear many kilometers away. Marine shells can be found far from the coast. Pigments and ornaments appear in places where the raw materials did not naturally occur. These objects are more than decorations. They are clues. A shell carried inland tells us that either a person traveled from the sea or the shell passed from one group to another. A piece of high-quality stone found far from its source tells a similar story. Someone moved, or something was exchanged. And exchange creates relationships. Picture a small group moving across a dry landscape. Among their possessions is a piece of red ochre. It came from a place none of the children have seen. Perhaps it was obtained from relatives. Perhaps it was exchanged during a seasonal gathering. Perhaps it traveled through several groups before reaching them. To us, it is a mineral. To them, it may have carried social meaning. It could have been used to color skin, objects, tools, or ornaments. It may have marked identity, belonging, age, status, memory, or ceremony. We cannot know the meaning. But the movement of such objects tells us that prehistoric people were connected by more than immediate survival. They maintained relationships across space. This matters because relationships can function like insurance. Modern humans understand this instinctively. When one household suffers, relatives may help. When one community faces difficulty, others may provide food, shelter, information, or support. The same basic principle can operate in small-scale societies. If one group has an unusually successful hunting season, another group may visit. If one region suffers drought, people may temporarily move toward relatives elsewhere. If a young adult needs a partner, social ties create opportunities beyond the local band. If a valuable stone source lies far away, connections can provide access. A population organized into many linked communities can absorb local disaster more effectively than the same number of people divided into isolated groups. This is where demography and culture begin to merge. A larger social world does not merely provide more friends. It creates resilience. Imagine one camp disappearing after a severe winter. If it belongs to a larger network, the empty territory may later be repopulated. Relatives return. Young families move in. Knowledge of the place survives in stories. The location of water, shelter, stone, and seasonal food remains part of collective memory. But if a small, isolated group disappears, its knowledge may disappear with it. No neighboring population remembers the hidden spring. No one knows the safe mountain passage. No one remembers where animals gather in late summer. An entire map can vanish from human memory without leaving any archaeological trace. This may help explain why population size is so important in discussions of Homo sapiens success. Culture is not stored only in objects. It is stored in people. If too few people remain, complex skills can disappear. Imagine a community in which only two individuals know how to produce a particular tool. One dies unexpectedly. The other never finds an interested apprentice. Within a generation, the technique is gone. This can happen even when the people are fully intelligent. Nothing has changed in their brains. What has changed is the number of opportunities for knowledge to be copied. Larger and more interconnected populations offer more opportunities. More tool makers, more learners, more experiments, more chances for a useful innovation to survive, more chances for one person to observe another person's solution. This creates what researchers often call cumulative culture. Cumulative culture means that knowledge can build over time. One person discovers something useful. Another person learns it. A third person modifies it. The next generation begins not from the beginning, but from the improved version. Then another improvement is added. The process continues. The final technology may be too complicated for any one person to invent from nothing. Yet a community can create it collectively across generations. Think about something as simple as clothing. A human body has no natural fur thick enough for a glacial winter. Biological evolution could eventually produce a different body, but that would take many generations. Culture works faster. An animal is killed. Its hide is removed. Someone discovers a better way to scrape it. Another discovers how to soften it. Someone develops a method of joining pieces. Eventually, shaped clothing becomes possible. Then needles allow tighter seams. Better clothing permits longer exposure to cold. Longer exposure opens new hunting grounds. New hunting grounds bring contact with new animals, materials, and neighboring groups. A small improvement can create a chain of consequences. The same is true of hunting. A spear point is not only an object, it is the end product of many decisions. Which stone should be chosen? How should it be shaped? How should it be attached? Which adhesive works? How long should the shaft be? At what distance should the weapon be used? What kind of prey is suitable? Where should hunters stand? How should they communicate during the hunt? Technology exists inside a social system, and a social system can preserve thousands of details that no single artifact reveals. This brings us to language. Few subjects in human evolution invite more speculation. Language does not fossilize. Words leave no bones. A sentence spoken 40,000 years ago disappears almost immediately into the air. We can study anatomy. We can study genes related to speech. We can study hearing. We can study tools and symbolic behavior. But we cannot hear the conversations of prehistoric people, so we must be careful. It would be misleading to say that Neanderthals could not speak. The evidence does not justify such certainty. They likely possessed substantial vocal and communicative abilities, possibly including forms of language far more sophisticated than old stereotypes allowed. The more useful question may not be whether Homo sapiens had language and Neanderthals did not. The useful question may be how communication interacted with the size and structure of social networks. Imagine a hunter returning to camp. He saw reindeer 2 valleys away. With simple communication, he can indicate direction and perhaps quantity. With richer language, he can describe the route. He can explain that the river is dangerous after heavy rain. He can describe a distinctive rock marking the safest crossing. He can say that the animals were moving north rather than feeding. He can warn that another human group is nearby. He can tell people when he saw them. He can compare this migration with one remembered from several years earlier. The more information that can be communicated accurately, the less each person must discover through personal experience. Language transforms experience into shared data, but it can do something even more powerful. It can transmit things that are not present. A person can describe yesterday, tomorrow, a valley beyond the horizon, a dead relative, a possible danger, a plan that has not yet happened, a rule, a promise, a relationship between 2 absent people, a story about why 2 groups should trust one another. That last ability may be particularly important. Large social networks require people to cooperate with individuals they do not see every day. Kinship helps. Marriage helps. Exchange helps. Shared symbols may help. Stories may help. Imagine 2 communities gathering near a river at the end of summer. Some individuals recognize one another immediately. Others have never met. Yet they may know that they belong to related networks. A particular ornament, a style of marking, a remembered family connection, a shared story. These things can make strangers less strange. They create categories of belonging. They allow cooperation to extend beyond immediate household relationships. This does not mean prehistoric Homo sapiens created enormous peaceful alliances across continents. Networks were probably unstable. Relationships could fail. Groups could fight. People could be excluded. But even limited connections across several communities would offer major advantages. One of the most important was access to partners. Small populations face a basic biological problem. People need mates who are not too closely related. If communities become isolated, genetic diversity declines. Finding partners can require movement between groups. Evidence from both genetics and archaeology suggests that prehistoric humans often moved among communities. Such movement connected populations biologically and culturally. A young person leaving one group and joining another carried more than genes. That person carried knowledge, methods of preparing food, ways of making tools, memories of distant landscapes, names of people, social obligations, perhaps songs, perhaps stories, perhaps different ways of organizing a hunt. Human migration was therefore also information migration. One person crossing a valley could become a bridge between two cultural worlds. This may explain why exchange networks matter so much, even when the exchanged objects appear trivial. A shell necklace does not feed anyone. A bead cannot kill a reindeer. Pigment does not keep a winter wind away. But objects can represent relationships. And relationships can provide food, partners, shelter, and knowledge later. The practical value of a symbolic object may lie in what it says about the person carrying it. I know these people. I belong to this network. My relatives live beyond that ridge. We have exchanged before. We remember one another. A small object can carry invisible social information. Now compare two populations again. Both are intelligent. Both make tools. Both hunt. Both care for children. But one population has slightly more extensive networks. When climate shifts, information moves faster. When a group loses members, outsiders join. When a technique is invented, it spreads farther. When local stone becomes unavailable, exchange supplies another source. When young adults seek partners, there are more options. When one region suffers, people have somewhere else to go. None of these advantages guarantees survival. But together they create resilience. This may have been one of the quiet strengths of Homo sapiens. Not extraordinary intelligence inside every individual, but extraordinary intelligence created between individuals. A human brain can forget. A community can remember. An individual can die. A network can preserve the person's knowledge. One hunter knows how to track horses. Another knows a distant source of flint. Another understands the plants that appear after spring rain. Another remembers a winter route. Another is unusually skilled at shaping bone. Another has relatives beyond the mountains. Connect those people, and the group possesses a form of intelligence that exists nowhere inside a single skull. This is collective intelligence. And once collective intelligence becomes cumulative, each generation can inherit a cultural world richer than the one before. But there is a danger in making this explanation too neat. We do not know that Neanderthals lacked such networks. They clearly moved materials across landscapes. They maintained social relationships. They learned from one another. There may even have been cultural exchanges between Neanderthals and Homo sapiens. The distinction was probably not absolute. Again, the important differences may have been matters of degree. A slightly larger population, a slightly wider network, more frequent contact, more reliable transmission, more distant exchange, more opportunities for innovation to persist. Evolutionary history can turn on very small differences repeated over very long periods. A 1% advantage feels meaningless in a single year. Across thousands of years, it can reshape the human world. And there is another consequence of connection. Connected populations can respond to environmental change with behavior rather than biology. If a region becomes colder, people can learn new clothing techniques. If large animals decline, they can adopt new foods. If a river changes course, knowledge of another route can spread. If unfamiliar territory is entered, local information can be exchanged or borrowed. This flexibility will become increasingly important as our story continues. Because the late Pleistocene world was unstable, temperatures did not simply become colder and remain there. Climate could shift dramatically. Vegetation zones moved. Animals changed their ranges. Regions that had once supported large human populations could become difficult. Other regions suddenly became attractive. A social network could help people respond, but it could not control the weather. And the weather of the Ice Age world could be merciless. There were periods when environmental conditions changed on timescales short enough to affect the lives of human communities. Forests could retreat across generations. Grasslands could expand. Rainfall patterns could change. Animal migrations could shift. Routes that once connected human groups could become difficult or disappear. When this happened, every population faced the same fundamental question. Could it change quickly enough? Some communities could move. Some could alter their diets. Some could adopt new tools. Some could connect with neighboring groups. Others might become trapped by geography or numbers. Once again, survival was not simply about intelligence. It was about options. A population with 10 possible responses to environmental stress has an advantage over one with 3. And connection creates options. It is possible to borrow an idea, move into another territory, join relatives, exchange resources, find new partners, learn another technique. Collective knowledge turns a landscape from an unknown wilderness into a map filled with possibilities. Perhaps this is why the movement of a small shell can tell us so much. Thousands of years later, an archaeologist may hold it in a laboratory. It weighs almost nothing. It may have no practical cutting edge. It may never have been used to hunt or butcher an animal. But if that shell was carried 100 kilometers from the sea, then it reveals something enormous. People were connected. Somebody knew somebody. Routes existed. Objects moved. Ideas may have moved with them. And perhaps, in the long struggle of the Pleistocene, such invisible lines between communities mattered as much as the weapons held in their hands. Imagine now the continent from high above. Night falls. Across the darkness, small fires appear. Some are Neanderthal camps. Some are Homo Sapiens camps. The individual flames look almost identical. But between certain Homo Sapiens fires, imagine faint lines. A person travels from one camp to another. A shell moves inland. A piece of stone moves east. A young woman joins another community. A hunter returns with news. An old technique spreads. A new idea is copied. The lines multiply. No one living beneath them sees the entire network. Each person knows only a small part. Yet together those relationships create something larger than any band. A cultural organism spread across the landscape. A form of memory that survives individual death. A form of insurance against local disaster. A system capable of accumulating knowledge. It may have been one of the most important advantages our ancestors ever possessed. But even the strongest network depends upon the landscape through which it runs. And during the Ice Age, that landscape never remained the same for long. The climate could redraw the map. A forest could vanish. A grassland could open. A migration route could shift hundreds of kilometers. A familiar valley could become empty. And when the environment changed, every human population had to change with it. In the next chapter, we will enter that unstable world. A world of advancing ice, retreating forests, shifting animals, sudden cold, and generations forced to adapt to new conditions. Because the next part of the mystery was written not only by humans, it was written by the climate itself. The Ice Age was not one long winter. It was something far more complicated. The climate of the late Pleistocene shifted again and again, sometimes gradually, sometimes with surprising speed. Cold phases deepened. Warmer intervals returned. Forests advanced across valleys and then retreated. Open grasslands expanded. Rivers changed. Animal populations moved with the vegetation. Entire regions that had once offered reliable food could become difficult within the span of a few generations. For the humans who lived through these changes, there was no weather forecast, no climate map, no written memory extending back centuries, only experience, only stories, only the landscape itself. Imagine a valley in Western Europe. At one point, it is bordered by woodland. Deer move beneath the trees. Streams run through the lower ground. People know where to find edible plants, where animals drink, and where shelter can be found during bad weather. Generations pass. The climate cools. The trees begin to thin. The open ground expands. Different animals become more common. Reindeer appear in larger numbers. Horses move across the grasslands. The people who remain must change what they hunt, where they travel, and perhaps even the seasons in which they occupy the valley. More generations pass. Conditions shift again. The landscape changes once more. For us, these transformations can be displayed in a graph. For the people living through them, they were life. A colder decade meant shorter growing seasons for plants. A shift in rainfall could affect water sources. Changes in vegetation altered the movements of grazing animals. The movement of animals altered hunting, and hunting affected whether children ate enough to survive the winter. Climate was never an abstract force. It entered the human body as hunger, cold, exhaustion, distance, and risk. This is important because discussions of human extinction sometimes describe climate as though it were a single disaster, a sudden freeze, a terrible winter. Then an entire population disappears. The evidence suggests a more complicated story. Neanderthals lived through dramatic environmental fluctuations for hundreds of thousands of years. They were not helpless in the face of climate. They had repeatedly adapted to changing habitats. Some Neanderthal populations lived in very cold environments. Others occupied wooded regions. Some lived near coasts. Some hunted large herbivores in open landscapes. They were flexible enough to survive many environmental transitions long before large numbers of Homo sapiens entered Europe. So climate alone cannot explain everything. But climate can weaken populations. And a population already small, fragmented, or under competition may be far more vulnerable to environmental instability than a larger, better connected one. Imagine two human groups facing the same difficult decade. The first has several neighboring communities. People can move between them. News travels. Young adults have multiple places to go. If one hunting territory becomes poor, another may still be productive. The second group is more isolated. Its nearest neighbors are several days away. Its population is smaller. A failed hunting season is not merely inconvenient. It may mean fewer children survive. A second difficult year may leave too few healthy adults. A third may force the group to abandon territory it has known for generations. The climate has affected both groups, but not equally. This is one of the great lessons of survival. The same environmental shock can produce very different outcomes depending on the structure of the population experiencing it. The late Pleistocene repeatedly tested that structure. Researchers studying ancient climate have found evidence of abrupt temperature changes during this period, especially in the northern hemisphere. Ice cores from Greenland preserve chemical records of changing conditions. Marine sediments preserve evidence of shifts in ocean circulation. Pollen trapped in sediments shows vegetation changing through time. Animal remains reveal movements in habitat and prey. These records show a world that could change dramatically. Cold phases could arrive. Warmer intervals could interrupt them. Habitats expanded and contracted. The familiar world refused to remain familiar. For a hunter, one of the most important consequences was the movement of animals. Human beings do not hunt an abstract category called prey. They hunt specific species in specific places. They must know how those animals behave, where they gather, where they give birth, where they cross rivers, how they react to danger, which season makes them vulnerable. This knowledge takes time to build. Now imagine that the animal population shifts north, or a forest replaces open grassland, or a drought affects a water source. The old knowledge does not suddenly become useless, but it becomes less reliable. People must learn again. They must explore. They must take risks. They must travel farther. A flexible population can adjust, but every adjustment has a cost. Distance means energy. Experimentation means failure. New prey means unfamiliar danger. Moving into new territory can mean encountering other humans. And that last point matters greatly. Climate did not act separately from competition. It could increase competition. If two populations depended on different regions, they might rarely meet. But if environmental change compressed both into the same productive valleys, encounters would become more frequent. A river corridor with reliable water could become more valuable. A sheltered cave could become more important. A rich hunting ground could attract multiple groups. Suddenly, climate changes the social map as well as the ecological one. This may have happened repeatedly as Homo sapiens expanded into Eurasia. The newcomers were not entering an empty continent. They were moving through territories already known and used by Neanderthals. In some places, occupation may have alternated. A cave contains one archaeological layer associated with Neanderthals. Above it appears material associated with Homo sapiens. In another region, the sequence may be more complicated. Dating is difficult. Layers can be disturbed. Artifacts can move. The farther back we look, the more cautious we must be. Still, the broad pattern is clear. Human populations were moving through a landscape already undergoing rapid environmental change. This makes the idea of a single final confrontation less convincing. The late Neanderthal world may instead have been one of repeated local pressures. A group loses access to a hunting territory. Another moves south. Another becomes isolated. A sapiens population arrives in a neighboring valley. A colder phase reduces local resources. A marriage joins two communities. A small group disappears. Another survives for several more generations. Over time, the map changes, not through one decisive event, through accumulation. This is how extinction often works. The final disappearance is dramatic when viewed from the future. The process itself may be almost invisible to the people inside it. Imagine a population declining by only a tiny amount each generation. No single year looks catastrophic. Children are still born. People still hunt. Fires still burn. but perhaps there are slightly fewer young adults than before. A neighboring band stops visiting. One valley is abandoned. Travel becomes harder. By the time the decline becomes obvious, recovery may already be difficult. This is especially dangerous for small populations because of something scientists call demographic vulnerability. You do not need a mass death event to create extinction. You need only enough bad luck. A run of years in which too few children survive. An imbalance between men and women. A few accidental deaths among young adults. A disease outbreak. A failed migration. A local food shortage. A period of inbreeding. Any one of these may be survivable. Several together can become devastating. And climate increases the probability of several happening at once. This may help explain why a population as capable as the Neanderthals could disappear after such a long period of success. Their adaptation to cold conditions was impressive, but adaptation is always adaptation to something. When conditions become unpredictable, flexibility may matter more than specialization. This brings us to a useful idea: the generalist and the specialist. A specialist is extremely effective within a particular set of conditions. A generalist can tolerate a wider range. Neither is automatically superior. In a stable environment, specialization can be an advantage. A predator perfectly adapted to one prey may outperform a more flexible competitor. A plant perfectly suited to one climate may dominate that environment. But when conditions change rapidly, specialization can become dangerous. The qualities that once produced success may become constraints. We should be careful not to label Neanderthals as simple specialists and Homo Sapiens as perfect generalists. Reality was more complex. Neanderthals exploited diverse environments and foods. Homo sapiens populations could also fail in unfamiliar landscapes. But there is evidence that Homo sapiens increasingly occupied an extraordinary variety of environments. African savannas, woodlands, deserts, coasts, tropical forests, cold Eurasian plains, high-altitude regions, eventually Arctic environments. This capacity did not come from the body alone. The human body changed relatively little compared with the environments being entered. Culture did much of the work. In a cold region, clothing became an artificial layer of insulation. Shelter created an artificial microclimate. Fire created warmth. Tools opened new food sources. Fishing technology turned rivers and coasts into reliable environments. Containers allowed food and water to be carried. Social information reduced the danger of unfamiliar territory. Culture allowed Homo sapiens to behave almost like a biological generalist, without waiting for slow genetic adaptation. This was a profound advantage. Consider a coastline. Large terrestrial animals may be scarce. A population dependent mainly on big game could struggle. But a community that knows how to collect shellfish, catch fish, hunt seabirds, gather plants, and exploit marine mammals has multiple options. If one resource fails, another may remain. This is called dietary breadth. A broad diet spreads risk. The same principle applies inland. Large mammals provide enormous amounts of food, but they can be dangerous and unpredictable. Small animals provide less meat individually, but they may be abundant. Birds, rabbits, fish, shellfish, seeds, roots, nuts, and other plant foods can supplement hunting. The broader the menu, the less a community depends on one ecological system remaining stable. Homo sapiens did not invent dietary flexibility overnight, nor did every population exploit every food source. But across the archaeological record, modern humans increasingly show evidence of diverse subsistence strategies. This matters because environmental change rarely removes all resources equally. A colder climate may hurt one plant but benefit another. A change in vegetation may reduce one herbivore and favor a different species. A drying lake may become less useful for fishing but create new opportunities elsewhere. The question is whether people can switch. Flexibility is the ability to answer a changing world with a changing strategy. Perhaps this is one of the reasons Homo sapiens survived. Not because our ancestors always knew what to do, but because their cultural systems allowed them to try more things. To borrow, to experiment, to combine, to move, to fail locally without disappearing everywhere. And movement may have been particularly important. Humans are unusual animals in our ability to live almost anywhere, but this does not mean we are naturally suited to every place. We survive by carrying environments with us: clothing, shelter, fire, food storage, tools, social relationships, knowledge. When conditions become difficult, humans can also move long distances. A migration is risky. People enter unfamiliar landscapes. Water sources are uncertain. Prey behavior is unknown. Other groups may already occupy the region. Yet movement can rescue a population from local collapse. A small group trapped in a declining environment has few options. A group connected to distant communities may relocate. Migration, therefore, links climate back to social networks. Information makes movement safer. A person who knows that relatives live beyond the mountains is not entering a completely unknown world. A group that has exchanged with people along a river already possesses part of the map. Connection turns geography into possibility. Now consider the opposite. What happens when climate breaks networks apart? A severe cold phase may make a mountain pass difficult. A drought may remove a water source along a travel route. A forest may retreat, changing where animals and people can move. A population that once met neighboring groups each season may become isolated. Exchange declines. Partner choice shrinks. Knowledge moves less frequently. The population becomes more vulnerable just when it most needs support. This feedback can be dangerous. Environmental stress creates isolation. Isolation reduces resilience. Reduced resilience makes future environmental stress more damaging. The lights between camps go dark, one by one. It is possible that some late Neanderthal communities experienced precisely this kind of process. Not everywhere, not all at once, but enough times to reduce an already small population. At the same time, Homo sapiens populations were expanding through parts of Eurasia. If sapiens groups were generally more numerous or more connected, they could occupy territory abandoned by Neanderthals. Once established, those populations might make it harder for Neanderthals to return. Competition does not require direct violence. Imagine a productive valley capable of supporting 40 people. A Homo sapiens group occupies it first. They hunt the same animals, collect the same firewood, use the same water. There may be no battle. The resources are simply no longer available in the same way. This is ecological competition. Over long periods, even small differences in efficiency or population growth can shift which group dominates a landscape. But once again, domination was not universal. Sometimes the two populations met and interbred. Sometimes technologies may have influenced one another. Sometimes territory changed hands repeatedly. The Pleistocene was not a chessboard with two armies. It was a moving patchwork of human lives. And beneath everything was the climate, always changing, always rearranging the possibilities. Picture the same European valley across 10,000 years. At first, trees stand along the river. A Neanderthal group uses a rock shelter above the water. Children play near the entrance. Smoke stains the ceiling. Later, the climate cools. The trees withdraw. Open grassland stretches farther. Reindeer become common. The human group changes its hunting. Centuries pass. The valley is abandoned. Wind carries dust into the old shelter. Bones accumulate. Sediment covers the hearth. Then another group arrives. Perhaps Neanderthals again. Perhaps Homo Sapiens. They make a new fire above the old one. They do not know that people once sat in almost the same place thousands of years before. Later still, conditions warm. Shrubs return. A different set of animals appears. Another human population follows. Layer upon layer, the cave becomes an archive. Fire. Silence. Fire again. Silence again. From these layers, archaeologists reconstruct a world that never stood still. And that may be the most important thing to remember. Evolution does not occur against a fixed background. The background moves. The rules change. The best strategy for one century may be less useful in the next. A population that appears perfectly adapted can become vulnerable without changing at all. The environment changes around it. Homo sapiens may have survived because our ancestors became unusually good at living with that uncertainty. They were not physically equipped for every climate. They created equipment. They were not born knowing every landscape. They exchanged information. They were not dependent on a single food. They expanded their diets. They were not tied permanently to one territory. They moved. And when they encountered other humans, they did not always replace them. Sometimes they absorbed them. But all of these abilities depended on another process. Knowledge had to become material. Ideas had to become objects. A plan had to become a spear. A hide had to become clothing. Bone had to become a needle. Fiber had to become cord. A branch had to become a projectile. A shelter had to become protection against winter. That is where the next part of our story begins. Because Homo sapiens did not conquer harsh environments with the body nature gave us. We changed the relationship between the body and the environment. We placed layers of technology between ourselves and the cold, the distance, the darkness, and the teeth of other animals. And many of the inventions that helped us do this were not spectacular. Some were so small that they could fit in the palm of a hand. Yet a tiny piece of worked bone could open an entire continent. In the next chapter, we will follow those objects. Stone blades, projectiles, needles, clothing, shelters, traps, fishing equipment, and the countless small improvements accumulated across generations. Because sometimes the difference between surviving a changing world and disappearing from it is not a great invention. Sometimes it is 1,000 little ones. The human body is not especially impressive when compared with the animals of the Ice Age. We do not have thick fur. We do not have claws. We do not have long canine teeth. We are not the fastest runners. We are not the strongest mammals. We cannot survive a severe winter simply by relying on the skin we were born with. And yet, Homo sapiens eventually entered environments that should have been deeply hostile to an animal with our anatomy. The reason was not that our bodies changed fast enough. It was that our technology changed the relationship between our bodies and the world. A human being does not need to evolve thicker fur if that human being can make clothing. A human being does not need stronger jaws if stone can cut meat. A human being does not need the speed of a horse if hunters can predict where the horse will run. A human being does not need claws if a blade can be held in the hand. Technology became a second body, a body made of stone, wood, bone, fiber, hide, fire, and accumulated knowledge. And this second body could change far more quickly than biology. Imagine a small camp somewhere in Eurasia around 40,000 years ago. The morning is cold. Smoke rises slowly from a fire. Near the edge of the camp, someone sits with a piece of stone. The stone itself looks ordinary, but the person holding it understands things that the stone does not reveal. Where it came from, how it fractures, which direction force must travel, which part should be struck first, which pieces are worth keeping. The toolmaker turns the core in one hand, then strikes. A thin blade separates. It is long, sharp, and useful. Another strike follows, then another. The point is not that Homo sapiens invented stone tools. Stone technology is far older than our species. Neanderthals were skilled stoneworkers. Earlier human populations had been shaping stone for immense stretches of time. The important question is not whether Homo sapiens alone possessed technology. They did not. The question is whether Homo sapiens increasingly developed a technological system that was broader, more specialized, and more cumulative. Stone was only one part of it. Wood almost certainly mattered enormously, even though wood rarely survives for tens of thousands of years. Plant fibers were probably used in ways the archaeological record struggles to preserve. Animal hides became clothing and shelter. Bone became tools. Antler became points. Sinew could bind objects together. Adhesives joined materials that would otherwise separate. A single finished weapon might contain the work of several different technologies. A stone point shaped precisely. A wooden shaft straightened and prepared. Binding material twisted or cut. Adhesive heated and applied. Each component had to work with the others. This was not simply tool use. It was engineering. And engineering creates distance between danger and the human body. Consider the difference between killing an animal at arm's length and killing it from farther away. Close hunting is dangerous. A wounded animal can charge. A hunter can fall. A broken leg in the Pleistocene can become a life-threatening event, even if companions provide care. Any technology that increases the distance between hunter and prey may reduce risk. Projectile weapons, therefore, matter enormously. Exactly when different forms of projectile technology appeared remains debated, and different populations use different systems. But Homo sapiens increasingly developed weapons that could be thrown, launched, or used at greater distances. A spear thrown by hand. A light projectile. Later, technologies that increased speed and range. The important change is not simply that a point became sharper. It is that the hunter no longer had to place the body as close to the animal. Every additional meter could matter. A successful hunt brings calories. A safer hunt preserves hunters. And preserving experienced adults is especially important in small populations. An adult hunter represents years of accumulated knowledge. Where animals move, how weather changes, how a wounded animal behaves, how to approach from downwind, where a herd may turn when frightened. Losing that person means losing more than muscle. It means losing memory. Technology that reduces risk therefore protects culture as well as life. Now, Move from the hunting ground back to the camp. Someone is working with bone. The object is small. It does not look powerful. It would never appear as dramatic as a stone spear point. But perhaps it will become a needle, a tiny object with an eye through which thread can pass. It may be one of the quietest inventions in human history. A needle allows pieces of material to be joined precisely. Hides can become fitted clothing rather than loose coverings. Sleeves can be made. Edges can be closed. Layers can be combined. Boots can fit more closely. Gaps that allow cold air inside can be reduced. In a harsh climate, these differences matter. A loose hide protects the body. Tailored clothing transforms it. With good clothing, people can remain outside longer, travel farther, hunt in colder conditions, carry children more safely, sleep in environments that would otherwise be dangerous. A needle does not merely make clothing. It expands geography. An object small enough to disappear beneath a handful of soil can help open enormous territories to human occupation. This is why technological history is often misleading when told only through spectacular inventions. The changes that matter most are sometimes modest. A better knot, a sharper edge, a lighter point, a stronger adhesive, a more efficient way to prepare hide, a new method of preserving food, a better container, a different way of arranging a shelter. Each improvement may save only a small amount of energy or reduce risk only slightly. But over thousands of days, small efficiencies accumulate, and over generations, accumulated improvements can transform survival. Consider shelter. A cave is useful, but caves do not exist everywhere. Even where they exist, the best caves may already be occupied by animals or other humans. A population that can construct effective shelters is less dependent on natural geology. Wood, hide, bone, branches, grass, and earth can create a protected space. The shelter blocks wind. The fire provides heat. Sleeping surfaces reduce contact with cold ground. People can occupy open landscapes far from caves. Once again, technology changes the map. The landscape is no longer divided simply into places where the naked human body can survive, and places where it cannot. Culture creates new categories. Places survivable with fire. Places survivable with clothing. Places survivable with shelter. Places survivable if food can be stored. Places survivable if water can be carried. This ability to construct a portable environment around the body may have been one of the defining strengths of Homo sapiens. But there was another technological transformation happening at the same time. The menu expanded. For large-bodied hunters, big animals are attractive. A single large kill can feed many people. Fat provides valuable energy. Bones contain marrow. Hides provide materials. Sinew can be useful. Yet large animals are not always available. They move. They reproduce slowly. They can be dangerous. And climate change can alter their distribution. A population dependent too heavily on one category of prey is vulnerable. So imagine a different kind of food gathering. Someone stands beside shallow water. Fish move beneath the surface. Capturing them efficiently requires different knowledge from hunting horses. The hunter must understand currents, water depth, seasonal movements. Perhaps fish can be trapped, perhaps speared, perhaps collected during particular migrations. Near a coast, shellfish can be gathered. Elsewhere, birds can be taken. Small mammals can be trapped. Seeds can be processed. Roots dug. Nuts collected. Different environments require different technologies. A large spear is useful against large prey. It is inefficient against a rabbit. A trap changes the equation. The trap works when the hunter is elsewhere. Human time becomes multiplied. A person can set several traps and return later. This is a profound idea. Technology can allow human effort to continue after the human leaves. A fire cooks while someone performs another task. A trap waits. Food dries in the air. A sharpened tool preserves labor already invested in it. A shelter remains standing. A container stores water for later. Technology rearranges time as well as space. And this creates more possibilities. One person can gather. Another can repair tools. Another can care for children. Another can prepare hides. Another can collect fuel. Tasks overlap. The community becomes more efficient. But efficiency alone does not explain why one human population survives while another disappears. Neanderthals also possessed substantial technological abilities. They made complex stone tools. They used fire. They processed animals skillfully. They sometimes used adhesives. They knew how to survive in cold environments long before Homo sapiens became widespread in Europe. So once again, the difference was probably not the existence of technology itself. It may have been the diversity, rate of change, and reliability with which technological knowledge circulated. This brings us back to cumulative culture. Imagine that someone creates a new hunting point. The design works slightly better. If the inventor belongs to a small, isolated group, the idea may spread to only 20 people. If that group disappears, the innovation disappears. Now imagine the same invention in a larger network. Visitors see it. A young person carries the design to another community. Someone there changes the hafting method. Another group experiments with a lighter shaft. A generation later, the original invention has become part of a larger technological tradition. No individual planned the final result. No single genius invented the whole system. The technology evolved socially. This may be one of the most important distinctions in human cultural history. Innovation is not enough. Innovation must survive. It must be copied accurately enough to persist, flexible enough to be modified, and widespread enough that the death of one individual does not erase it. Population size matters. Networks matter. Teaching matters. Observation matters. Perhaps language matters. Technology is therefore not separate from the social world described in the previous chapter. It grows from it. A blade moving between groups carries an idea. A traveler who demonstrates a new technique carries an idea. A marriage between communities carries an idea. A child watching an older relative carries an idea into the future. And successful ideas accumulate. This does not mean every generation improves everything. Technologies can be lost. People can abandon complex methods when simpler ones are sufficient. Environmental changes can make old tools irrelevant. Entire traditions can disappear. Cumulative culture does not move in a perfectly straight line. But large connected populations create more opportunities for useful knowledge to survive disruptions. Now imagine what this means during climate instability. The world becomes colder. A community improves clothing. Animals change. Hunters modify weapons. Large game becomes unreliable. People exploit smaller prey. A familiar region dries. Containers allow water to be transported. Wood becomes scarce. Fuel use changes. A coastal migration route opens. Fishing becomes more important. Every environmental challenge creates a problem. Culture creates possible answers. Not always good answers. not always enough. But answers that can appear within years rather than evolutionary millennia. Biological evolution cannot give a population a new body in one difficult winter. Culture can give it a new coat. It cannot grow claws. It can create blades. It cannot change human teeth into those of a predator. It can cook. It cannot make the human arm powerful enough to kill every animal safely. It can create projectiles. Technology allowed Homo sapiens to respond to environmental change at the speed of learning. And learning can happen within a lifetime. That difference is enormous. There is also another consequence. Technology can permit specialists to exist within communities. If every person must know every survival skill equally well, the complexity of the cultural system may remain limited. But in larger social networks, some people may become unusually skilled at particular tasks. One person may be an excellent stoneworker. Another may know plant materials. Another may understand hunting routes. Another may make ornaments. Another may know distant groups. Specialization need not resemble modern professions. But differences in expertise create opportunities for knowledge to deepen. A skilled toolmaker produces objects others can use. Others provide food or materials. The group as a whole gains capabilities no individual possesses alone. Once again, many brains become more powerful than one. This is why a technological advantage cannot easily be separated from population and social organization. The spear is connected to the toolmaker. The toolmaker is connected to the learner. The learner is connected to another community. That community is connected to a distant source of stone. The stone is connected to a hunting strategy. The hunting strategy is connected to clothing that allows hunters to remain outside in the cold. Everything is linked. Survival becomes a system. And systems can become resilient when they contain many alternatives. If one food fails, another is available. If one tool breaks, another can be made. If one community loses a specialist, another can teach the skill again. If one region becomes hostile, technology may allow people to move. This does not make Homo sapiens invulnerable. Our ancestors died in enormous numbers. Entire populations disappeared. Migration attempts failed. Communities became extinct. People starved. Children died. Technology did not remove the danger of the Pleistocene. It shifted the odds. And small shifts in the odds matter over thousands of generations. A slightly lower hunting mortality rate. A slightly broader food supply. Slightly warmer clothing. Slightly more efficient transport. Slightly more reliable knowledge. Each difference is modest. Together, they can become decisive. This may be why the search for one revolutionary Homo sapiens invention has never fully solved the mystery. Perhaps there was no single technological breakthrough that separated us from every other human population. Perhaps the real breakthrough was the system that allowed many technologies to accumulate. A system in which an improvement made by one person could survive beyond that person's lifetime. A system in which ideas could move with people. A system that could combine materials, knowledge, social networks, memory, and experimentation. In other words, the important invention may not have been a particular tool. It may have been the cultural machinery that kept producing tools. And still, if Homo sapiens possessed all these advantages, another mystery remains. When our ancestors entered Eurasia, they did not simply move through empty landscapes. They met people, Neanderthals, Denisovan-related populations, perhaps other groups whose names we do not yet know. If Homo sapiens merely outcompeted these populations, We might expect their biological stories to end completely, but they did not. Something of them remains, not only in caves, not only in stone tools, not only in fragments of bone buried beneath ancient sediment. Their traces survive inside living people. The discovery of ancient DNA transformed the story of human evolution. It showed that encounters between human populations were not always endings. Sometimes they were unions. A Neanderthal and a Homo Sapiens could become parents. A Denisovan-related person and a Homo Sapiens could produce descendants whose genes would travel tens of thousands of years into the future. Some of those inherited genes may even have helped later humans survive new environments. This changes the meaning of disappearance, because a population can cease to exist as a separate people while part of its ancestry continues. Extinction can also be absorption. The apparent loser can become part of the survivor. So in the next chapter, we will leave tools behind and turn to something much smaller, something invisible without modern science. DNA. We will follow ancient fragments recovered from bones and teeth. We will see how they overturned one of the simplest stories ever told about human evolution. And we will discover that the vanished humans of the Pleistocene may not be as vanished as they first appear. For a very long time, the story seemed simple. Neanderthals lived in Europe and Western Asia. Homo sapiens arrived. Neanderthals disappeared. One population replaced another. The old humans vanished, and the new humans inherited the land. It was a clean story, almost too clean. Then, at the beginning of the 21st century, scientists began recovering increasingly detailed genetic information from ancient human remains. And hidden inside that ancient DNA was a different history. A history in which the lines between human populations were not walls. They were bridges. Our ancestors did not only compete with other humans, they sometimes had children with them. And those children survived. Their descendants survived. Generation after generation, fragments of DNA inherited from those ancient encounters traveled forward through time. They crossed the Ice Age. They passed through the invention of agriculture. They survived the rise and fall of civilizations. They passed quietly through millions of births. And today, tens of thousands of years after Neanderthals disappeared as a distinct population, pieces of Neanderthal ancestry remain inside many living human beings. The people who vanished from the landscape did not completely vanish from the human story. To understand how extraordinary this discovery was, imagine an archaeologist opening a box containing a fragment of ancient bone. It does not look like a historical revolution. It may be small, broken, discolored by soil. For decades, a fossil like this could tell researchers about anatomy. Its shape might reveal whether it came from a Neanderthal, Homo sapiens, or another ancient human. Its geological layer might suggest its age. Chemical traces might hint at diet. But the deepest information remained invisible. Inside the bone, under favorable conditions, tiny fragments of genetic material could survive. DNA, the molecular record of biological inheritance. Recovering ancient DNA is extremely difficult. After death, genetic material begins to break apart. Heat damages it. Water damages it. Microorganisms introduce contamination. Modern human DNA can enter a sample through handling. In warm tropical environments, ancient DNA may degrade so badly that little remains. Cold caves and frozen environments can preserve it much better. For years, scientists developed increasingly careful methods to separate genuine ancient genetic material from contamination. Then the fragments began to speak. One of the most important discoveries came from Neanderthal remains. Researchers compared Neanderthal DNA with the genomes of living humans from different regions of the world. If Neanderthals and the ancestors of living Homo sapiens had remained completely separate, the genetic pattern should have reflected a clean division. But they did not. Many living people whose ancestry is primarily outside sub-Saharan Africa carry roughly a small percentage of DNA inherited from Neanderthal populations. The exact percentage varies. The exact pieces vary from person to person, and ancient population movements have made the modern pattern complicated. But the central conclusion is secure. Homo sapiens and Neanderthals interbred, not once in one strange isolated event. The genetic evidence points to multiple episodes of contact and gene flow across different places and times. Imagine what that means in human terms. Somewhere in Western Eurasia, perhaps tens of thousands of years before agriculture, two people met. One belonged to a Homo sapiens population. The other belonged to a Neanderthal population. We do not know how they met. We do not know whether their groups had known one another for years. We do not know whether the relationship was peaceful, violent, arranged, temporary, or affectionate. DNA cannot preserve emotion. It records only descent. But a child was born, and that child became part of a chain of ancestry that did not end. This happened often enough for Neanderthal genetic material to enter populations whose descendants later spread across enormous areas of Eurasia and beyond. A fossil can tell us that two populations occupied the same broad region. DNA can tell us that sometimes they became family. This transformed the old replacement model. The disappearance of Neanderthals could no longer be described as a complete erasure. Their communities vanished as recognizable, independent populations. Their archaeological traditions faded. Their distinctive anatomy ceased to exist as a living population. But some of their genes remained. And Neanderthals were not the only ancient humans whose genetic traces survived. Return now to the Altai Mountains of Siberia. There, among the forests and cold valleys, lies Denisova Cave. The cave had been used by humans at different times across an immense span of prehistory. When researchers examined a tiny finger bone recovered from the cave, they expected it might belong to a known ancient human group. Instead, its DNA revealed something surprising. The individual belonged to a population genetically distinct from both modern Homo sapiens and Neanderthals. A previously unknown branch of the human family had appeared not first through a complete skeleton, but through genetic information. These people became known as Denisovans. Later discoveries added teeth and bone fragments. But the physical record remained remarkably small compared with the importance of the genetic evidence. From those fragments and from DNA in living people, an enormous story began to emerge. Denisovan-related populations had contributed ancestry to some modern human populations. The strongest Denisovan genetic signal is found among many peoples of Oceania, including populations in New Guinea and nearby regions, although Denisovan ancestry also appears in varying amounts across parts of Asia. This created a geographical puzzle. How could genetic ancestry related to people identified in a Siberian cave appear so strongly among populations thousands of kilometers to the southeast? The most likely answer is that the Denisovan world was never limited to that cave. Denisovan-related populations probably occupied wide areas of Asia. Perhaps several populations related to one another lived in different regions. Some may have been adapted to forests, some to colder environments, some to high mountains. We possess only fragments of their bodies, but their genes suggest a much larger human geography. One of the most remarkable examples comes from the Tibetan Plateau. Living at high altitude creates a severe biological challenge. The air contains less oxygen. For people whose bodies are not adapted to such environments, physical activity becomes difficult. Long-term exposure can create serious health problems. Yet Tibetan populations possess genetic adaptations that help them function in thin mountain air. One important gene region associated with this adaptation, commonly discussed in relation to a gene called EPAS1, appears to have entered the ancestors of Tibetan populations through ancient interbreeding with a Denisovan-related population. Think about that slowly. A population of Homo sapiens entered Asia. At some point, ancestors of living humans interbred with another ancient human lineage. Genetic material passed between them. One of those inherited variants later became highly useful in an extreme environment. An encounter between two human populations tens of thousands of years ago helped provide descendants with a biological advantage at high altitude. The ancient humans were not merely obstacles on the road of Homo sapiens expansion. Sometimes they were sources of useful genetic variation. This process is known as adaptive introgression. The phrase sounds technical, but the idea is simple. One population carries a genetic variant. Another population interbreeds with it. The variant enters the second population. If the inherited trait is useful in the environment, natural selection may increase its frequency. Interbreeding can therefore allow evolution to borrow. Instead of waiting for a useful mutation to appear independently, a population may acquire an existing adaptation from another lineage. The same principle applies to some Neanderthal-derived genetic variants. Researchers have identified inherited Neanderthal DNA associated with aspects of immunity, skin biology, metabolism, and other traits. The effects are complicated. Ancient variants that were useful in one environment may have neutral or even unfavorable effects in another. A gene does not come labeled as good or bad. Its consequences depend on the biological and environmental context. But the wider lesson is clear. When Homo sapiens entered Eurasia, our ancestors were moving into environments that other humans had inhabited for very long periods. Those populations had their own evolutionary histories. Their bodies carried adaptations shaped by local conditions. Through interbreeding, some of that biological history entered Homo sapiens. In a sense, our ancestors sometimes adapted to Eurasia, not only by inventing new technologies, but by inheriting pieces of earlier human adaptation. This makes the survival of Homo sapiens even more interesting. We often imagine survival as preserving purity. A species succeeds by remaining itself. But human success may have depended partly on the opposite: flexibility, contact, mixture, the capacity to absorb genes from closely related populations. Homo sapiens did not cross the Pleistocene world sealed inside a biological boundary. Our lineage was porous, and the other human lineages were porous as well. Genetic evidence shows that Neanderthals and Denisovans also exchanged genes with one another. One extraordinary individual discovered through DNA had a Neanderthal mother and a Denisovan father. She lived tens of thousands of years ago. Her existence is a direct reminder that the categories we use today were not barriers that ancient people necessarily experienced in the same way. We call one population Neanderthal, another Denisovan. another Homo sapiens. These names are necessary for science. They allow us to discuss evolutionary relationships. But the people themselves did not live inside our taxonomy. They encountered individuals, faces, voices, bodies, strangers, potential partners, rivals, relatives. The evolutionary tree was becoming a network, and this changes the word extinction. Suppose a small Neanderthal population consists of several hundred people spread across a region. A much larger Homo sapiens population expands into the area. Some Neanderthals die without descendants. Some leave. Some communities remain isolated. But others interbreed with sapiens. Their children become part of increasingly sapiens-dominated communities. Those children have children of their own. Over generations, the distinctive Neanderthal population becomes smaller. Eventually, there is no independent Neanderthal community left. From an archaeological perspective, Neanderthals have disappeared. From a demographic perspective, the population has ceased to exist separately. But genetically, part of it continues. No one final individual needs to die alone for extinction to occur. A population can dissolve into another population. This does not mean all Neanderthals were peacefully absorbed. Many almost certainly left no descendants. Their populations were already small. Environmental pressure continued. Competition may have mattered. Some groups may simply have died out. But assimilation adds another mechanism to the story, and it helps explain why asking who won can be misleading. If two rivers meet, which river survives? Downstream, the water contains both. One channel may lose its name, but its water continues. Human ancestry can work in a similar way. This is especially important because ancient genetic studies have revealed that our own species was never a single uniform population either. Homo sapiens evolved in Africa through a complicated history involving populations that separated, reconnected, migrated, and exchanged genes. Later, as humans moved across Eurasia, those patterns became even more intricate. Populations split. Some died out. Some returned. Some mixed with Neanderthals. Some mixed with Denisovan-related humans. Some groups left little ancestry in people alive today. Others expanded dramatically. The human family tree is therefore not a ladder leading neatly toward modern humanity. Nor is it a simple tree whose branches never reconnect. It is more like a forest of streams. They divide. They wander. They cross. Some dry out. Some merge. And from those ancient channels flows the ancestry of living people. There is something deeply strange about realizing that the body can function as an archive. Most archives contain paper, stone inscriptions, photographs, recorded voices. But every living human carries another kind of archive. DNA contains traces of ancient population history. Not a complete record, not a perfect biography, but fragments. Some of those fragments entered our ancestry before Homo sapiens became the only surviving human species. A person living today may carry small stretches of DNA descended from a Neanderthal who lived in the Pleistocene. Another may carry Denisovan-derived ancestry. The individual ancient person is gone. Their language is gone. Their face is unknown. Their personal memories disappeared tens of thousands of years ago. Yet something inherited from their body remains alive. This is one of the most intimate ways the past can survive, and it forces us to reconsider the emotional meaning of those ancient disappearances. Neanderthals are gone. That statement is true. There are no Neanderthal communities living in Europe today. There are no Neanderthal languages being spoken. No Neanderthal child is learning how to shape stone beside a fire. The cultural continuity of those populations ended. The same appears true for Denisovan populations as distinct human communities. Their independent worlds vanished. That loss is real, but extinction was not absolute erasure. Some biological inheritance crossed the boundary. Perhaps cultural knowledge crossed it as well. This is much harder to prove. Ideas do not leave genetic signatures. If Homo sapiens learned a particular technique from Neanderthals, or Neanderthals learned from Homo sapiens, archaeology may not always reveal the direction clearly. Yet whenever populations meet, observation becomes possible. A different way to prepare a tool, a new use for pigment, a hunting method, knowledge about a landscape, a useful plant, a safe route. Human beings have always been capable of watching one another. It would be surprising if genes crossed between communities while ideas never did. So perhaps Homo sapiens' survival involved more than outcompeting other humans. Perhaps it also involved learning from them, absorbing them, becoming partly descended from them. The survivor changed through the encounter. This leads to an uncomfortable but fascinating conclusion. Homo sapiens may have become the last surviving human species, partly because Homo sapiens was capable of incorporating parts of the others. Survival did not require remaining untouched. It may have required becoming more mixed, more genetically diverse, more culturally flexible, more capable of carrying useful pieces of many histories forward. Now imagine two people sitting beside a fire roughly 50,000 years ago. One is Neanderthal. One is Homo sapiens. Their faces are different. Their bodies carry hundreds of thousands of years of partially separate evolutionary history. Perhaps their voices sound different. Perhaps their communities make tools differently. Perhaps each finds the other unfamiliar. Neither knows what a chromosome is. Neither knows the word DNA. Neither knows that scientists in a distant future will reconstruct fragments of their ancestry from old bones. They certainly do not know that one day people will ask which of them survived. Because from their perspective, there is only the present, the fire, the cold air, the people nearby, the next journey, the next meal, the next child, and perhaps that child belongs, in some sense, to both worlds. Thousands of generations later, the distinction becomes blurred. The Neanderthal population disappears. The Homo sapiens population expands. But the child has descendants, and those descendants carry both histories forward. This is why the story of human survival cannot end with the language of conquest. It is partly a story of replacement, partly competition, partly extinction, but also inheritance, mixture, absorption, and continuity hidden inside change. Still, Neanderthals and Denisovans were only part of the ancient human world. Far to the south, beyond seas that Ice Age travelers somehow crossed, other human populations lived on islands. On Flores, small-bodied humans followed their own evolutionary path. On Luzon, another mysterious lineage left only a handful of bones and teeth. Elsewhere in Asia, genetic evidence hints at populations whose fossils may still be waiting to be recognized. By the later Pleistocene, those remaining branches also fade from view. But they did not all disappear in the same place. They did not face the same climate. They did not have the same population size. They did not necessarily encounter Homo sapiens in the same way. Their endings remind us that there was never one extinction event. There were many, different landscapes, different populations, different pressures, different final chapters. In the next chapter, we will leave the familiar caves of Neanderthal Europe and travel outward across Asia and the islands of Southeast Asia. We will follow the faintest branches of the human family tree, some known from only a few bones, some known partly through genes, some perhaps still hidden beneath layers of earth. And we will watch, slowly, as the world of many human lineages becomes the world of one. Not in a single battle, not on a single day, but through thousands of small disappearances until, at last, only Homo sapiens remains. By the time we reach the final tens of thousands of years of the Pleistocene, the human world is already becoming quieter, not silent. Not yet, but quieter. The great family of human lineages that once spread across Africa, Europe, Asia, and the islands of Southeast Asia is beginning to narrow. In one region, a population disappears. In another, a human lineage survives for thousands of years longer. Farther east, a group leaves behind only teeth and fragments of bone. Elsewhere, there may be no fossils at all, only faint genetic evidence preserved in living people. There is no single last day. There is no final gathering where the surviving branches of humanity stand together and wait for history to choose one. Instead, there are many endings, separate endings, quiet endings, endings that take place in different climates, different landscapes, and perhaps for different reasons. To understand this final phase, we have to leave Europe. We have already spent time with Neanderthals in the cold valleys and grasslands of the West. Now we travel east across the enormous interior of Asia. The distances are almost difficult to imagine. Mountain chains, deserts, steppe, river systems, forests, high plateaus, places separated from one another by weeks or months of travel on foot. Somewhere within this vast geography live Denisovan-related populations. Their physical remains are extraordinarily scarce. A few teeth, fragments of bone, a jaw discovered on the Tibetan plateau, genetic material preserved in ancient remains. Yet the small quantity of fossils should not be confused with a small history. The genetic traces tell us otherwise. Denisovan-related ancestry survives across a wide portion of Asia and Oceania. This suggests that what we call Denisovans may not have been a single small population living around one Siberian cave. They were probably part of a larger and more diverse set of ancient human groups. Some may have occupied cold northern environments. Others may have lived farther south. Some were present in or near high-altitude regions. Others may have lived much closer to tropical environments. Their world was probably broad, but most of it remains invisible. This is one of the strange realities of human evolution. The archaeological record does not preserve importance fairly. A population can exist for tens of thousands of years and leave only a few fragments that we recognize. Another may inhabit a cave where preservation is excellent and leave behind a rich record. The first population is not less significant. It is simply less visible to us. Imagine a Denisovan-related group moving through a valley in Central or Eastern Asia. The air is cold. A mountain range rises in the distance. Their clothing, tools, language, family structure, and stories are unknown to us. Perhaps they hunt in ways similar to neighboring populations. Perhaps they use techniques we have never identified. Perhaps children learn routes through mountains that have been known for hundreds of generations. Perhaps the group meets other humans only rarely. Then, at some point, Homo sapiens enters the region. Once again, the encounter does not need to resemble a battle. There may be curiosity, avoidance, exchange, competition, interbreeding. The genetic record tells us that contact occurred, but it does not preserve the faces involved. One human population becomes more numerous. Another becomes more fragmented. Some individuals enter mixed communities. Some groups move elsewhere. Over time, a separate Denisovan identity disappears from the archaeological and genetic landscape as an independent population. But again, the ancestry continues. Farther south, the story becomes even more unusual. We cross into Southeast Asia. During the Ice Age, sea levels are lower than they are today. Large amounts of water are trapped in continental ice sheets. Coastlines extend outward. Some islands become connected to mainland regions, but not all of them. Deep ocean channels remain, and beyond some of those channels lie islands where human beings had somehow arrived long before modern history. One of those islands is Flores. There, in a tropical landscape of forests, volcanic ridges, streams, and unusual animals, lived Homo floresiensis, small-bodied humans. Their existence challenged nearly every comfortable assumption researchers once held about the human family. The first well-known remains from Liang Bua Cave revealed an adult body dramatically smaller than that of most modern humans. The skull was small. The anatomy contained a strange mixture of features. Some seemed surprisingly ancient. Others reflected an evolutionary history shaped by island isolation. At first, the discovery seemed almost impossible. How could such a human lineage survive until relatively recent prehistory? How had its ancestors reached Flores? The island was separated from the surrounding land by water even during periods of low sea level. Some kind of water crossing had occurred. Whether deliberate or accidental, human ancestors reached the island and remained there. Over long periods, isolation transformed them. Island evolution often produces unusual body sizes. Large animals can become smaller when food is limited and predators are absent. Small animals can sometimes grow larger. On Flores, dwarf elephant relatives once lived alongside giant rodents and large reptiles, and among them lived small humans. Imagine the island at dusk. The heat of the day begins to fade. Birds move through the canopy. Insects become louder. Smoke rises from near a rock shelter. A group of Homo floresiensis returns with food. Children move close to the adults. Someone tends a fire. Someone carries a stone tool. The world beyond the sea is enormous. But this is their world, and it may have remained their world for an extraordinary length of time. Then the archaeological traces fade. The youngest securely dated evidence associated with Homo floresiensis appears to end tens of thousands of years ago. The exact relationship between their disappearance and the arrival of Homo sapiens in the wider region remains uncertain. This uncertainty matters. It is tempting to create an elegant story. Modern humans arrive. The small people of Flores disappear. Therefore, modern humans cause their extinction. But archaeology rarely gives us such clean proof. Climate may have changed. Volcanic activity may have altered the environment. Animal communities may have shifted. Population size may already have been small. Homo sapiens may have introduced competition. Disease may have played a role. Several pressures may have overlapped. We do not know. And saying we do not know is not a weakness. It is one of the most important disciplines in reconstructing prehistory. The temptation to fill silence with certainty can create stories more satisfying than the evidence allows. Flores teaches us to resist that temptation. Now move north toward the Philippines. On the island of Luzon, another human lineage left traces in Calao Cave, Homo luzonensis. Again, the evidence is fragmentary. Teeth, small bones from hands and feet, fragments from several individuals, enough to reveal a distinctive combination of anatomical traits, not enough to reconstruct their entire appearance or way of life. These humans lived tens of thousands of years ago on an island that also required some form of water crossing to reach. Their presence raises the same profound question. How many human populations once existed in island Southeast Asia that we have not yet discovered? Tropical environments are cruel to ancient remains. Heat accelerates decay. Acidic soils destroy bone. Genetic material breaks down quickly. Sea level changes have submerged enormous areas that prehistoric people once occupied. Important sites may now lie beneath coastal waters. Entire human histories may have disappeared with the landscapes that contained them. What we know may therefore be only a fraction of what once existed. Some populations may never receive scientific names. Their bones may never be found. Their tools may be impossible to distinguish from those of neighboring groups. Their only surviving trace may be a genetic pattern that does not fit the simple family tree. These are sometimes called ghost populations. The term is almost poetic, but the ghosts are not supernatural. They are missing chapters. Populations whose existence is inferred because the ancestry of living or ancient humans contains contributions that seem to come from an unknown source. A group existed. It met another group. People had children. Those descendants survived. But the original population remains largely invisible. How many such groups existed? We cannot say with confidence. The human past becomes less complete the deeper we look. And this makes the disappearance of multiple human lineages even harder to reduce to one cause. Neanderthals lived across Europe and Western Asia. Denisovan-related populations occupied parts of Asia. Homo floresiensis lived on an island. Homo luzonensis lived on another island. Other ancient populations may have inhabited tropical forests, mountain regions, or coastlines now drowned beneath the sea. Their environments were different. Their population sizes were different. Their histories of contact with Homo sapiens were different. Why should their endings be identical? They probably were not. For some groups, demographic fragility may have been decisive. Island populations can be especially vulnerable. Imagine a community of only several hundred people separated from all other humans by sea. A severe volcanic eruption affects vegetation. Large prey declines. A storm destroys a productive coastal area. Disease spreads through the population. A generation is born with fewer surviving children. There is no neighboring valley filled with relatives. There may be no larger population from which new people can arrive. Isolation, which once protected a unique lineage, can become a trap. For another population, climate may be the stronger pressure. For another, contact with Homo sapiens may create competition. The newcomers may exploit more food sources. Their numbers may grow faster. Their networks may extend farther. They may occupy the best water sources or hunting grounds. No battle is necessary. Over generations, the smaller population finds fewer places to live. For another group, the most important process may be interbreeding. Members are absorbed into a larger Homo sapiens population. Their descendants survive, but the separate community does not. For still another group, disease might matter. When populations separated for long periods meet, they may carry different pathogens and different immune histories. We have no direct evidence allowing disease to explain all ancient human extinctions. It should not be used as an easy answer, but in principle, unfamiliar infections could have affected contact between populations. Even small changes in adult mortality or childhood survival can matter greatly when population size is already low. And then there is chance. Chance is uncomfortable. Humans prefer explanations that reward strength, intelligence, or preparation. We like to imagine that survivors possess the qualities necessary to survive. But evolution contains contingency. A storm strikes one coast and not another. A volcanic eruption occurs near one population. A hunting accident removes several experienced adults from a small band. A migration route opens during one generation and closes during the next. A disease reaches one valley. A child who would have had many descendants dies young. A group takes the eastern path instead of the western one. Tiny events can change the ancestry of future continents. If we could replay the Pleistocene again from 50,000 years ago, we cannot assume that every outcome would repeat exactly. Perhaps Neanderthals survive longer. Perhaps a different Homo sapiens migration fails. Perhaps an island population remains isolated for another 20,000 years. Perhaps a particular episode of interbreeding never happens. Perhaps another human lineage contributes more ancestry to future populations. Evolution is not a story written in advance. There is no final page toward which nature is trying to move. This is essential when we look back at Homo sapiens. We know the ending. That knowledge creates an illusion. Because we survived, we begin to interpret every earlier feature of our species as evidence that survival was inevitable. A wider network becomes proof of destiny. A projectile becomes proof of superiority. A symbolic object becomes proof of greater intelligence. But people living at the time had no such guarantee. Homo sapiens populations also disappeared. Many migrations ended without leaving major descendants. Some early movements outside Africa appear to have contributed little to later populations. Communities failed. Lineages vanished. Our species survived as a whole, but countless individual Homo sapiens populations did not. What mattered was that enough populations remained connected, mobile, numerous, and adaptable to keep the wider lineage alive. That may be the true advantage, not immortality, redundancy. If one group failed, another survived. If one route closed, another remained. If one tradition disappeared, related knowledge survived elsewhere. If one region became uninhabitable, populations existed in other regions. Homo sapiens increasingly spread risk across geography. Eventually, our species occupied such a wide range of environments that no single local catastrophe could easily remove everyone. This was not the condition of the other surviving human lineages. Many appear to have been smaller, more geographically limited, more fragmented. Once their numbers fell below certain thresholds, recovery became increasingly difficult. A population can survive extraordinary hardships for hundreds of thousands of years and still disappear quickly once several pressures overlap. This is not contradiction. It is demography. Imagine a rope made from many strands. Cut one strand and the rope remains. Cut another and it remains. Eventually, enough strands are gone that the next small break causes the entire structure to fail. Looking backward, we may focus on that last break. But the true cause lies in everything that weakened the rope before it. Ancient human extinction may have worked in much the same way. Climate pressure, small numbers, isolation, competition, limited access to partners, loss of knowledge, disease, interbreeding, random accidents. Each removes a strand. Eventually, a distinct population can no longer maintain itself. And so, across the late Pleistocene, the human world slowly changes. Neanderthal fires disappear from Europe and Western Asia. Denisovan populations cease to exist as recognizable independent groups. On Flores, Homo floresiensis vanishes from the record. On Luzon, Homo luzonensis leaves only a few traces. Other unnamed human populations disappear so completely that we know them only through faint genetic echoes, if we know them at all. The family tree becomes narrower, yet the world does not become culturally simple. Homo sapiens populations spread into new landscapes and diverge from one another. Languages multiply. Technologies change. Regional traditions develop. People adapt to deserts, forests, coasts, high mountains, grasslands, and cold northern environments. Human diversity continues, but it is now diversity within one surviving species. Eventually, Homo sapiens reaches Australia. Later, populations move into the Americas. Humans settle remote islands. Much later still, agriculture reshapes societies in several parts of the world. Villages become towns. Towns become cities. Written history begins. By the time anyone begins writing about the origin of humanity, the world of multiple human species is already unimaginably ancient. No cultural memory clearly preserves it. No living Neanderthal remains to tell us what happened. No Denisovan voice survives. No story from Flores reaches us intact. We forget that humanity was once plural. For thousands of years, Homo sapiens lives without knowing that other kinds of humans once shared the planet. Their bones are buried beneath cave floors. Their tools are mistaken for stones. Their genetic fragments pass invisibly from parent to child. Only much later do we begin to uncover them again. A skull emerges from a quarry. A tooth appears in a cave. A small skeleton is excavated on an island. A fragment of bone produces unexpected genetic results. Piece by piece, the lost family returns. Not alive, but visible. And with every discovery, the question becomes more difficult. Why us? Why did this one lineage continue while the others ceased to exist independently? By now, we have gathered many pieces of the answer. Population size, social networks, shared knowledge, technological flexibility, broader diets, mobility, adaptation to many environments, interbreeding, and chance. No one factor is enough. Together, they form a pattern. Perhaps Homo sapiens was not the strongest human. Perhaps not the most perfectly adapted to any one landscape. Perhaps not dramatically more intelligent at the level of the individual. But our species may have become unusually good at keeping options open. More people to turn to. More foods to eat. More places to move. More tools to use. More knowledge to share, more communities to reconnect with after disaster, more opportunities to borrow useful genes and perhaps useful ideas from the humans we encountered. When the world changed, Homo sapiens could often change with it. Not always, but often enough, and perhaps often enough, is all evolution requires. Now imagine the Earth around the end of the Pleistocene. From far above, you see deserts, forests, rivers, ice, mountains, coasts, and grasslands. Humans live across enormous portions of the planet. Their faces differ. Their cultures differ. Their languages are already branching into forms we will never recover. They have no shared global identity. No one knows the size of the planet. No one understands the full history of the human family. Yet biologically, something profound has happened. Every living human community now belongs to the same surviving species, Homo sapiens. The age when several human lineages shared the earth is over. There is no ceremony marking the transition. No final announcement. The last independent population of another human lineage disappears somewhere, at some time, without leaving a written record. Perhaps the end comes through death. Perhaps through absorption. Perhaps through both. And after that moment, whenever it truly occurred, one human species remains. Us. But the word us is now more complicated than it seemed at the beginning, because some of those extinct populations became part of our ancestry. Some of their genetic adaptations survived. Their existence shaped the environments into which our ancestors moved. Their competition influenced our migrations. Their presence altered our evolutionary history. Their disappearance did not leave Homo sapiens unchanged. The survivor was shaped by the people it survived alongside. So we have arrived at the final question, not whether Homo sapiens survived. We know that we did. The question is why. Was it population? Connection? Language? Technology? Ecological flexibility? Interbreeding? Luck? Or did all of these forces combine in proportions that changed from one region to another? In the final chapter, we will gather the evidence together, not to declare one simple winner and one simple cause, but to understand why survival itself may have been a mosaic, 1,000 small advantages, 1,000 accidents, 1,000 encounters, 1,000 decisions made by people who never knew the future depended on them. And perhaps, when we finally ask why Homo sapiens was the last human standing, we will discover that the most important word in the question is not strongest. It is adaptable. So now we return to the question with which our journey began. Why did Homo sapiens survive? Why are we the only remaining human species? Why did Neanderthals disappear as a distinct population? Why did Denisovan communities fade from the record? Why did the small-bodied humans of Flores vanish? Why did Homo luzonensis leave behind only a few bones and teeth? And why, after a world once filled with several kinds of humans, did only one lineage remain? The most accurate answer is also the least dramatic. There was probably no single reason, no single weapon, no single mutation, no single moment of genius, no single battle, no simple dividing line between a superior species and an inferior one. Instead, the survival of Homo sapiens appears to have emerged from a combination of advantages, pressures, accidents, encounters, and historical contingencies that unfolded across thousands of years. The first advantage may have been numbers. Population size matters more than it seems. A large population can lose people and recover. A small population can lose people and collapse. A larger population contains more potential parents, more skilled adults, more children, more teachers, more hunters, more memory, and more variation. If one group experiences famine, another may survive. If one community disappears, neighboring communities may move into the empty region. If a toolmaker dies, another may preserve the technique. If a local population becomes isolated, people from other groups may restore connections. Numbers create resilience. They create redundancy. And redundancy is one of the quiet secrets of survival. Homo sapiens may have possessed larger or more interconnected populations in many regions than Neanderthals did. This does not mean every Homo sapiens group was large. Many bands were probably small. But those groups may have been embedded within broader social networks. That leads to the second advantage: connection. A human being alone possesses a limited memory. A community possesses more. A network of communities can possess vastly more. Information about animals, water, stone, weather, distant landscapes, dangerous routes, safe shelters, seasonal gatherings, potential partners, useful plants, better tools. All of this can move through relationships. One person knows something. Another learns it. Someone carries it across a valley. Another person teaches it to a child. Over generations, knowledge becomes less dependent on any single individual. This may have made Homo sapiens unusually good at preserving solutions. Not necessarily inventing everything first, preserving, sharing, combining, improving. That difference is important. A brilliant invention that dies with its inventor changes nothing. A modest improvement copied by thousands of people may transform history. This is where cumulative culture becomes powerful. A stone point is improved. A hafting method becomes more reliable. A hide is cut more efficiently. A needle produces better clothing. A trap saves time. A fishing method opens a new food source. A shelter design makes winter travel safer. None of these developments must be revolutionary alone. Together, they widen the range of environments humans can occupy. Which brings us to the third advantage: ecological flexibility. Homo sapiens did not become successful by adapting to one perfect environment. Our species became successful by entering many: savannas, forests, deserts, grasslands, coasts, river valleys, mountains, cold northern plains, eventually some of the most difficult environments on Earth. The human body alone was not enough. Culture completed the adaptation. In cold climates, clothing substituted for fur. In dangerous hunts, weapons substituted for claws and teeth. In unfamiliar landscapes, social information reduced uncertainty. In regions where large animals were scarce, broader diets created alternatives. This ability to shift strategies may have made Homo sapiens more resilient when climate repeatedly changed the rules. And the climate did change the rules. The late Pleistocene was unstable. Cold periods deepened. Warmer intervals returned. Forests expanded. Grasslands retreated. Animals shifted their ranges. Water sources changed. Travel routes opened and closed. The human population that survived was not necessarily the one best adapted to one specific landscape. It may have been the one best able to leave that landscape when conditions changed. Flexibility can be more valuable than perfection. A specialist may dominate a stable world. A generalist may survive an unstable one. But we should not turn this into another oversimplification. Neanderthals were not incapable of flexibility. They had already survived repeated climatic shifts. They occupied varied habitats. They changed hunting strategies. They used different resources. The distinction was probably not absolute. It may have been a difference in degree. A slightly broader diet. A slightly larger network. A slightly faster spread of innovation. A slightly higher population density. A slightly more reliable supply of partners. A slightly greater ability to recolonize abandoned territory. Each difference on its own seems small. Over several thousand years, small differences become history. Then there is technology. Technology did not make Homo sapiens invincible. It changed probabilities. A projectile that reduces hunting danger preserves experienced adults. A needle improves clothing. Better clothing allows longer exposure to cold. A container makes water portable. A fishing technique expands the food supply. A trap gathers resources while people perform other tasks. A better shelter extends the range of habitable places. Technology is powerful because it allows cultural change to occur much faster than biological evolution. A body cannot evolve thicker insulation in one generation. A community can make better clothing in one generation. A population cannot evolve a new jaw overnight. It can invent a new blade. A person cannot grow claws. A person can carry a spear. This ability to solve biological problems culturally may have given Homo sapiens a decisive kind of flexibility. But technology itself depended on social transmission. Tools are not separate from people. They must be taught, copied, maintained, carried, modified. If populations are too small or isolated, complex technologies can disappear. If populations remain connected, innovations can spread. Once again, everything returns to networks. Now consider another factor. Diet. Large animals provide large amounts of food, but they are risky. They move. They can disappear from a region. They reproduce slowly. They can injure hunters. A population that relies heavily on a narrow range of prey is vulnerable when those animals decline. Homo sapiens increasingly exploited a broad variety of foods. Fish, shellfish, birds, small mammals, plants, roots, seeds, nuts, large game. Different communities specialize differently, but the wider pattern suggests remarkable flexibility. A broad diet acts like a portfolio of survival. When one food declines, another may remain. This reduces the chance that one ecological change destroys the entire subsistence system. Then there is mobility. Homo sapiens moved. Again and again. Some migrations failed. Some left almost no descendants. Others carried populations into new continents. Movement allowed humans to escape local ecological collapse. It also allowed them to enter regions abandoned by other populations. But migration was dangerous. It required knowledge. People needed water, shelter, food, routes, connections. Mobility therefore worked best when combined with social networks and technology. This is a recurring theme. The advantages were not independent. They reinforced one another. Larger populations create more social links. More social links spread technology. Technology allows wider diets and longer migrations. Migration creates new contacts. New contacts provide partners, ideas, and genetic exchange. Genetic exchange can provide useful biological variation. Useful variation can improve survival in new environments. The system becomes stronger because its parts interact. And that brings us to one of the most surprising advantages of all: interbreeding. Homo sapiens did not remain biologically isolated from the humans we encountered. We mixed with Neanderthals, with Denisovan-related populations, possibly with other ancient groups we have not yet fully identified. Those encounters contributed genetic variation to later Homo sapiens populations. Some inherited variants may have affected immunity. Others influenced skin biology or metabolism. The Denisovan-related variant associated with high-altitude adaptation in Tibetan populations is one of the clearest examples. The survivor did not simply replace the other humans. The survivor incorporated part of them. That is a very different evolutionary story. It suggests that one strength of Homo sapiens may have been permeability, the ability to absorb. Biologically, perhaps culturally, we became successful not by remaining untouched by the world, but by changing through contact with it. And then there is the factor we rarely enjoy discussing: luck. Evolution is full of chance. A volcanic eruption does not ask which population is more intelligent. A disease does not care which group has better tools. A severe winter can strike one region harder than another. A migration route can close unexpectedly. A hunting accident can remove an experienced adult from a small community. A few years of poor birth survival can destabilize an already fragile population. A population with only a few hundred individuals can be altered profoundly by events that would barely affect a population of tens of thousands. We often look backward and turn survival into proof of superiority. The survivors survived, therefore they must have been destined to survive. But that logic is circular. Homo sapiens survived because enough Homo sapiens populations happened to endure enough crises. That does not mean extinction was impossible. If history could be restarted from 50,000 years ago, the outcome might not be identical. Perhaps Neanderthals survive in parts of Europe for much longer. Perhaps another Homo sapiens expansion collapses. Perhaps Denisovan-related populations remain distinct in Asia. Perhaps different lineages mix in different proportions. Perhaps the last surviving human world contains more than one species. We cannot know. That uncertainty is not a weakness in the story. It is one of its deepest truths. Evolution has no script. There is no hidden force pushing history toward modern civilization. There was no guarantee that cities, telescopes, mathematics, or written language would appear. There was no guarantee that the people who would create those things would belong to Homo sapiens. The future was open. Our existence is the result of an enormous chain of survival. One child lives. One parent finds food. One group survives winter. One community joins another. One traveler carries knowledge across a mountain. One population escapes drought. One relationship produces descendants. One genetic variant survives. One migration succeeds. Repeat that process across tens of thousands of years, and eventually we arrive here. More than 8 billion Homo sapiens now live on Earth. At night, our cities shine across the continents. Roads connect places that once required months of travel. Aircraft cross landscapes that ancient humans spent generations exploring. Satellites orbit above the same mountains that once separated tiny communities. In laboratories, scientists extract genetic fragments from bones older than agriculture. They reconstruct genomes from people who never saw a city. They identify relationships between populations separated by tens of thousands of years. We are now capable of looking backward into a time when we were not alone. And perhaps this is where the meaning of the question begins to change. Why did we survive while they disappeared? The phrase creates two sides, us and them. But biology has already blurred that boundary. If you carry Neanderthal-derived ancestry, where exactly does them end and us begin? If a Denisovan-related genetic variant helps modern humans live at high altitude, is that ancient population truly absent from the present? Their communities are gone. Their languages are gone. Their cultural worlds are gone. That loss should not be minimized. But ancestry can survive without identity. Fragments can remain after the whole has disappeared. Imagine once more a Neanderthal sitting beside a fire. Not a symbol, not a species diagram, a person. This person feels cold, feels hunger, recognizes family, knows familiar faces, remembers places, has probably experienced fear, perhaps grief, perhaps affection, perhaps curiosity. Across the fire sits another human, Homo sapiens. Their bodies differ. Their ancestry differs. Their communities may see one another as outsiders. Yet somewhere in encounters like this, the boundaries become porous. Children are born. Generations continue. Eventually, the Neanderthal population disappears, but the descendants remain. Now imagine a Denisovan-related person on a high plateau or in an Asian valley. The same principle. A life lived without any knowledge of the future. A meeting, a child, an inherited fragment carried onward. The vanished humans become part of the surviving one. This is why our final answer cannot be triumph. Homo sapiens did not win because we were strongest. We did not survive because every other human was inferior. We survived because a particular combination of population, connection, adaptability, technology, diet, mobility, interbreeding, geography, and chance allowed our lineage to persist when the others no longer remained separate. And even then, we survived partly by becoming entangled with them. Perhaps that is the quiet lesson of the Pleistocene. Survival is not always domination. Sometimes it is flexibility. Sometimes cooperation. Sometimes borrowing. Sometimes movement. Sometimes remembering what others discovered. Sometimes changing fast enough when the world changes. Sometimes simply enduring long enough for conditions to improve. And sometimes survival is luck. Now look at Earth from far above. Night covers one side of the planet. Cities glow along coastlines and rivers. Roads form webs of light. More than 8 billion members of one surviving human species sleep, work, travel, speak, remember, and dream. Almost none of us will ever see a living Neanderthal. No Denisovan community remains to tell us its own story. The small humans of Flores no longer walk beneath tropical trees. The voices of Homo luzonensis are gone. And yet their history is not entirely outside us. It survives in caves, in tools, in sediments, in bones, in genetic fragments, and in the questions we are now capable of asking. Perhaps then, the final question should not be, why did we survive while they failed? Perhaps it should be something gentler. How much of them helped make us possible? How many encounters shaped the lineage that remained? How many forgotten people contributed to the human world without leaving names? How many tools were copied? How many routes were shared? How many children carried two ancient ancestries forward into one future? We may never know. But when we look far enough into the past, the boundary between them and us begins to dissolve. Neanderthals, Denisovans, Homo sapiens, the humans of Flores, the humans of Luzon, and perhaps others still waiting beneath the ground. They were not separate stories unfolding on separate worlds. They were different chapters of one deep evolutionary history, a history of migration, adaptation, loss, connection, mixture, and survival, the history of a family, our family, and perhaps that is the most fitting thought with which to leave the ancient world tonight. We are alone now as a surviving human species. But we did not arrive here alone. Thank you for staying with us until the very end of tonight's journey through the deep history of humanity, here at Ancient Calm History Nights. We believe the past is best explored slowly, quietly, and with a little wonder before sleep. If you enjoyed this story, please support the channel by liking the video and subscribing for more peaceful journeys into history. And if you would like to help us grow, leave a comment and tell us what forgotten world, civilization, or mystery you would like to hear about next. Your support allows. Calm History Nights. To keep bringing long, relaxing stories from the distant past to your evenings. Until our next journey, thank you for listening. Sleep well, and may history accompany you gently into the night.